Greetings, folks. I'm Brian Benz. I'm a cloud advocate at Microsoft, and welcome to the Launch Space Show. We're going to be talking today about Kubernetes on Azure. We have a keynote speaker, Brendan Burns, who is the corporate vice president at Microsoft, and he is also the co-founder of Kubernetes. Now, just before we start talking to Brendan, I do want to show a little agenda on the screen. So today, Brendan's going to be talking about Kubernetes innovation, which is basically the latest on Kubernetes. Then we're going to talk about AKS, Azure Kubernetes Service, recent announcements, and a roadmap of what's to come. We're going to skip over to Azure Arc after that, recent announcements for Arc-enabled servers, Kubernetes and GitOps. Then AKS on Azure Stack HCI. After that, a first look at Open Service Mesh, OSM, on integration with AKS. And we're going to wrap up with identity management using Dapper. So got a good show for us. Let's get started with Brendan.
Cool. Hey, how's it going?
Doing good, doing good. How are you, sir?
Good. Thanks for having me to kick this off, and excited to be here. So I wanted to run through some of the work that my teams have been doing over the last semester or so, culminating in KubeCon, but we really kind of try and have exciting features coming out all the time, right? Rather than being date-driven about, a package of things to launch at a particular conference. We kind of have continuous innovation going on. I'm going to start out with the Open Service Mesh, which you mentioned. Which is there's going to be a much deeper dive on it later on with Phil, which is great. But over a little while ago, we launched the Open Service Mesh, which is a service mesh implementation open source project out on GitHub. It's intended to be a simple to use service mesh. I think we have a lot of people who are out there who are thinking about how do I get started with service mesh. But they may only have, relatively simple needs like end-to-end encryption or experiments, and it can be a pretty daunting thing to get started with. And so the Open Service Mesh is really intended to be an easy-to-use service mesh that can grow and scale with you. We've recently released the 0.5 release of that, and really kind of beefed up things like the end-to-end testing suite, so that we're headed towards production stability, ensuring that that it works the way it's supposed to work, which is always a good thing. As part of that, we've gotten it actually out into the CNCF as the Cloud Native Compute Foundation, which is the sort of umbrella organization for a lot of these open source projects. And that, I think, is a really great thing because it enables us to have vendor neutral collaboration, right? So people can take dependencies, people can come and collaborate and contribute to it, with the knowledge that this isn't a Microsoft project, it's not an Azure project, but it's actually out in the community project. So that's a big step forward. And then also, one of the most important things about OSM is that it's an implementation of the service mesh interface spec, which was a general open spec that we actually created with collaboration with a number of other people more than a year ago. And the real the important bit of the service mesh interface is that there's a lot of different service meshes out there, and we don't want people to have to be tied to an API to a specific implementation because it may change over time. You may find bugs. You may just decide you need a different implementation in different environments. And so it's really important to have that sort of interoperability layer. And you see this in Kubernetes throughout, like in the storage layer or in the Open Container Initiative. There was a lot of talk a couple days ago about how the Kubernetes project is removing Docker and focusing on containerd for the container interface. And I think people didn't initially realize that like all Docker containers are open containers, and there's this spec that is there so that you don't have to have the complete Docker toolchain in order to run these containers because they implement a spec, right? So this generic spec that people can implement is an important part of interoperability. And so the service mesh interface plays that role for service meshes. We've been making a lot of progress on that spec, actually, and actually had community members from both Red Hat and AWS join in with us there recently. So that's a great, because obviously these specs are only valuable if they're cross-industry, right? And so it's been great to see the progress there as well. And so, continuing to push both on the open implementation of the spec, but also on the independent spec, so that other people, HashiCorp or Linkerd or other people, can come along and implement the same spec, and people have a choice of service meshes that they want to be able to use. That's pretty cool. So, and as I said, Phil's going to talk about that later on.
Sure.
We've also done a bunch of work with with Azure Arc to think about how we do service mesh for both AKS and Azure Arc, and integrating service mesh into those solutions. One of the other things that we do a really great job of integrating into both Arc and AKS is policy. And I think policy is another great example of how we do open collaboration in the industry, but then also bring it back to our products. So there's a project that we actually kickstarted a long time ago called Gatekeeper, which is a policy engine in the open policy framework for Kubernetes. So if you want to be able to say things like, in a lot of compliant or regulated industries, you need to be able to establish policy that says, hey, look, in order to run an image in your cluster, it has to come from this one registry, because we know that we have the right kind of security on that registry. We know that we're doing, looking for vulnerable images. We know that, like, the only place we can pull images from is there, and the only way to express that is through Kubernetes policy. Or similarly, and you might want to say, hey, only people who have gone through a security review can create a service that is out on the public internet. Right? These are the kind of like compliance processes that companies need to be secure. The only way to ensure something like that in Kubernetes is through policy. And so, we went out, built up a cross-industry coalition in the CNCF project called Gatekeeper to develop policy. Because again, like if there's lots of different ways of doing it, it's not good. Like you need one solution that everybody in the industry uses. But then we also took it back, and we took it back into AKS and Arc as part of the product, because obviously our customers, they don't really want to be like pulling random open source projects off the internet and figuring out how to run them. They want us to take care of that for them, right? And so I think that we have a lot of this really nice blend between open cross-industry innovation, but then bringing it back home to a product so that an Azure customer can rely on it, can effectively call up my engineers 24/7 if they have a problem, or know that we're going to monitor it proactively and find problems even that they may not even notice, right? And so I think that that's a really important piece of how we do both open innovation in the Kubernetes ecosystem, but also meet our customers with what they need in order to be successful with these applications in their real world. The other thing that we've done with in that sort of same vein in open source and into the product is this idea of pod identity. So another really important part of compliance and other kinds of activities is least privilege, and also understanding what applications are doing what, right? And so if your individual containers or your individual layers in your application, like your front end or your middle tier or your back end, if they don't have independent identities, then it's very hard to say who's accessing the database, right? But if you can give your front end an identity, and you can give your middleware an identity and your back end identity, you can actually set up access control so that, maybe the front end really shouldn't be able to access the database, but the middle tier should. So you can have, a managed identity in Active Directory associated with your front end, and it can have very limited permissions, maybe just to pull down a certificate. The middle tier, has its own identity, and it has access to the database. Maybe it doesn't have access to the certificate because it shouldn't be serving on the public internet anyway. So you can do that kind of fine-grained access control, and also in the audit logs see, that oh, this was the middle tier doing this. So if it gets compromised somehow, you can actually see. I mean, obviously, hopefully it doesn't happen, but like you can actually see the requests and audit trace and look for anomalies in the way that the middle tier is accessing. So pod identity is the way that we go and do that. It's again an open source project that was developed out on GitHub. But it's being integrated with AKS as a supported part of AKS, and it's being integrated with Arc as a supported part of Azure Arc. And so it's really awesome, I think, to see that blend of being able to do work out in the open with both the broader community, but also our community of customers, but then also bring it back to the product. Speaking of AKS, I think we've had a pretty amazing semester. AKS continues to be the fastest growing service in the history of Azure. Which, I mean, a little bit of that's timing. I have to admit that, like, you know, AKS started at a point when cloud was maturing and growing really fast anyway. And so we gain a little bit of the tailwind of the overall, and not to mention COVID as well, and the sort of tailwinds of people really moving very quickly to cloud as they need to grow in response to, you know, the remote aspect of everything. But also it's a testament to the service itself that we've focused really a lot on the fundamentals and getting all the pieces to the right places so that the service can be used for those like life critical production things.
Yeah, I've actually
I've
really been interested in some of the services that are running top of the Kubernetes service, like the Spring Azure service and a few others. Those are really great. Being able to have another service, perhaps by a third party provided, that can run on top of AKS seamlessly without actually knowing that AKS is running underneath it, is really a great feature as well.
So. Yeah, we're seeing a lot of that both in terms of third parties, but also even in terms of our large scale not first parties, but large scale customers who have platform teams where they may not be running a platform built by someone else, but they build a platform for the rest of the company. So you have a team of 15 platform enterprise architect engineers who build up a higher level platform on top of AKS. And then the broad base of app developers in that company, well, they just have a Git repo and they push code into that Git repo or whatever the process happens to be. We're seeing a lot of that kind of like custom paths, if you will, that people are building specifically for their companies, which is pretty cool.
You mentioned security as well. That's really important. I mean, I remember a couple of years ago, you really couldn't tell when you went on Docker Hub if you were getting an official, real container of something that was provided by a legitimate provider versus something that was not. And that's really changed a lot recently. And of course, we have private container registries as well that you can use. But the security really, really is an important aspect of that as well. Being able to.
Yeah, for sure. I sort of joke that, like, it's not clear to me why, but somehow Docker made everyone forget that downloading random binaries off the internet was probably a bad idea, right? Like, just because there was a different interface that wasn't your web browser, suddenly everyone was like, sure, I'll download this random thing. And, you know, and clearly I think we've matured a little bit since then. And frankly, we've done a lot of really great work with Azure Security Center as well. Because while it's definitely the case that malicious images are a problem, a lot of the problems that we've seen have actually come from misconfigurations, right? Have come from people leaving, web interfaces, putting a web interface up on the public internet that was never intended to be on the public internet. Right. And it's not it's not unique to Kubernetes. I mean, there's lots of stories of people putting development databases, MongoDB, up on the public internet and getting scraped. I mean, it's a common problem. And again, I think that's part of why things like policy are so important, because people should not be able to accidentally do things like that. Right. Like you can't trust that you're going to train people to do the right thing. You have to have automation that's going to catch it. Right, like people will always make mistakes. People will always forget. Even people who know how to know the right thing that they should be doing, they'll just make mistakes, you know. And so you can't trust. You have to have the machinery to protect things. So it could be the best of intentions, but they might let something get old and it has some vulnerabilities, and all of a sudden your systems are vulnerable. So yeah, that's part of it too. I mean, I think that one of the things we also realized with AKS is that it's not like AKS isn't a thing in the vacuum, right? AKS is part of living with Security Center, living with GitHub, because like you need both the signal that says, hey, we looked at the images you're running and that image is old and there's a CVE. It was secure when you deployed it, or we thought it was secure when you deployed it, but a new CVE has been discovered. But then also the GitHub and GitHub Actions side of the house, where you need to be able to rev a new version, right? Like it's great to know that you have a problem, but if you can't roll out new software, it's hard to fix it, right? So I think that AKS is a piece of the puzzle, but the great thing about Azure and Microsoft generally is like we have all of the other pieces that are necessary to really operate your application securely and at scale. So absolutely. Hey, you mentioned
all the different components we have and all the moving parts for Azure. How are we making that easier for users these days? What have we added recently that is helping users visualize and deploy and manage things securely with policy, et cetera?
Yeah, I mean, I think there's a lot of different pieces to this, honestly. Absolutely, as we've sort of transitioned from the early adopters to the sort of late adopters and beyond, what we're seeing is people who they really want more opinions, right? Like in the early adopter phase, people just kind of want you to give them something, and then they're going to play around, and they really want to try all the things, and they're really excited about getting deep and learning stuff. I think in the late adopter phase, people just have a job to do, right? They've been told like, hey, you need to launch this app, and we're launching it on Kubernetes, and so they just they want to get from point A to point B as securely and reliably as possible. And so we're doing a lot more to provide streamlined experiences so that you don't have to make as many choices effectively, right? So like stuff like the GitHub Actions work that we did, so that if you want to set up a deployment to AKS, we can actually you can just use that GitHub action. You just a little bit of YAML in your GitHub repo, and you're ready to go to deploy into that cluster. Surfacing a lot more kind of cluster health metrics and stuff like that of the AKS cluster, and making people more aware of what's going on as well is another really important piece of that, so that they can understand how their service is operating. But I also think that we have to provide some higher level experiences as well. And so, for example, there's CADA, the Kubernetes event-driven autoscaler that was developed out of the Azure Functions team. That can be used, and they just hit a 2.0 release, and that can be used to provide functions as a service experience on top of Kubernetes, right? Because for many developers, asking them to figure out even how to build and push a container may be a bridge too far, right? And they really just want to take that little snippet of JavaScript and push it and have sort of the magic happen to make it run somewhere. And then while it's great to have that service as an Azure service in Azure Functions, there's a lot of environments where, like on-prem at the edge, where they don't have the Azure Functions running, or alternatively, like they may be doing function style programming, but someone else is doing more traditional container Kubernetes development, and those services need to interoperate together. And so having that ability to have different kinds of programming models in the cluster to enable different teams to collaborate together is a pretty big win. And I think that's an area where we're continuing to invest. We're going to continue to see innovation going forward. The Kubernetes itself, I just having this big discussion with the founder of Chef on Twitter the other day about like the potential for things on top of Kubernetes, and whether what that looks like. And I think it's Kubernetes itself is mostly baked. You continue to make changes, but it's mostly baked. But the real area where there's a ton of open space and development and honestly experimentation that's needed is in that space of developer productivity on top, and how do we make it simpler for people to do the right things easily, right? Like to fall into that pit of success instead of sort of stumbling around. And so I think that's going to be an area that we continue to work on for a very long time. I think Kubernetes is sort of to take a Microsoft analogy, like Kubernetes is sort of DOS right now, right? And we're sort of stumbling our way towards Windows 98, and that is sort of, I mean, that took 10 years, so like that maybe even a little more, so I think that's the sort of maybe the 10-year journey that we're now on, is how do we get there?
Nice. Yeah. What about so when you mentioned things running on top of Kubernetes, how do you sort of reconcile the intersection of open source community work and the product work that we're doing at Microsoft, and connecting the two together and cooperate?
Yeah, I talked about a little bit about that earlier, about how we think about we need to be doing open innovation, especially in areas where we need to be cross industry. But ultimately, people expect a product that's going to just work. If it has problems, they have somebody they can call and talk to. That is going to. So I think that what we think about when we think about open source and the product is, if it's something that needs to be cross industry, if it's something that's like what I would call undifferentiated heavy lifting, there's no real reason for it to stay in a closed environment. Those are all things that we're going to go open source, because we need to build community, or because it just makes sense to put it out there. And then there's other parts where, it just doesn't make sense. Like, it's very specific to running the Azure Kubernetes service, right? Like implementing the resource provider for the Azure Kubernetes service. No one else other than us is going to ever need to do that. So, that's a place where we keep things, more in-house. And I think that's the right balance in my mind. I think in a lot of cases with this open technology, the thing that people want to pay for isn't the intellectual property, it's the support and the operations. And so it doesn't matter that you take, the code and you make it open, because the product is effectively running it for people and enabling them to forget about the fact that they have it running and just let you handle upgrades. And so, like with the Kubernetes service, we're on the embargo list, so that if there's a vulnerability, we get notice of that ahead of time, so we can make sure that our customers are patched and secure on day zero, right? Yeah. And that's the kind of thing that people want to pay for, and frankly don't want to do themselves, right? And so I think that's great, because it means that we can do a lot of our innovation out in the open and yet still have something of value to sell as part of the product that we put forth. Cool. And I think especially in that broad market, that's really where people are. They're looking for you to just sort of take care of things for them, make their lives easier.
Absolutely, sort of a platform that you don't really need to think about, and then you can actually focus on actually doing the job that you have to focus on. So absolutely.
Yeah, for sure.
Speaking of community, adding OSM and other projects that we have for the Cloud Native Compute Foundation. What was it like to work with the CNCF, and how did the whole process happen?
So it's been great. Actually, I just had a CNCF technical oversight committee meeting this morning, where we were actually discussing some projects in their various stages. I was actually really pleased that the Helm project, which we're a major contributor to Helm, just reached graduated status in the CNCF. So graduated is like you've proven all the way through, like you can't go any further than being graduated. And it's a mark that like there's a large community and it's stable and production grade. And so CNCF has graduated, and then incubation, which is, we think you're on the right track. We think you're going to get to graduated eventually. And then Sandbox, Sandbox is actually in some ways the most interesting, because there's a lot of people out there who want to be in CNCF, to open the doors to collaboration, so that multiple companies who might be competitors can actually come and collaborate on source code without worrying about enabling their competitor. And so we've always struggled with, like, how do we put a bar there so that, like, we don't just take absolutely everything, but how do we also make it really wide open and enable innovation and not cut things off too early. And there's only a small number of us on the technical oversight committee, and so with Sandbox, we've actually basically put a pretty formal list of, like, if you do these things, we'll put you in Sandbox, right? If you have a code of conduct, if you have more than one company, if you're out on checklist style, so that we can run through and just like go through quickly. And I think that if people are thinking, hey, I have this idea, we're working on it, does it make sense to put it into the CNCF? I think that one of the things we really are looking for in that Sandbox process is, do you have collaboration, right? Like, if it's just your project, it's probably not ready yet, because we're looking for, the CNCF is set up to facilitate collaboration. And so, but if you're in a place where, 3 or 4 companies are coming together, but it's in somebody's personal repo, and people are starting to say, yeah, but where's the copyright going? What is the license? What's the licensing like? What about trademark? Like those are all really good reasons to start, putting things into the CNCF sandbox. As well as I think some of the basics of like good project health, like a code of conduct, right? Things that are just essential these days for ensuring that we build healthy communities. And Sandbox itself now is very sort of automated and lightweight. So you basically fill out a form, it goes into a spreadsheet. Once a quarter, we go through and review all of them in the spreadsheet. And probably 85% of the projects that go through that process get pushed into Sandbox. And then from there, it's a little more complicated to get to incubated. You got to really show some user interest and show some cross company collaboration. And obviously, graduated is an even higher bar, and that's why I think it's so great that Helm made it this recently. But yeah, it's a great place, and it's fun to hang out with a bunch of other people from around the industry, right? And even in these remote times, and we were all on video before, so actually COVID hasn't really affected that feel any. So
it's all virtual travel.
Yeah,
Right.
no, well, I mean, it was always virtual anyway. I mean, it's funny. There's people from Europe, there's people from Asia on that call. Time zones make it a little hard to find the right slot, but we work on it.
Sure, absolutely. When you say, you were talking a little bit about licensing and code of conducts and things like that. Are those provided by the CNCF, or are those each project have their own that they decide to use, and how does that actually work?
Yeah, so the CNCF exists as part of the Linux Foundation.
Okay.
And so some of this stuff comes from the Linux Foundation. Some of the stuff like the code of conduct is CNCF specific and is required. There is one code of conduct. You can't just have any code of conduct. You have to have, there is a single code of conduct because that consistency is really important.
Yeah.
For licensing, people tend to use Apache 2, although it is possible to have other licenses as long as they're open source licenses.
Sure.
And then for governance is probably the place where the CNCF is the loosest. We have some ideas about we want to make sure that projects aren't dominated by a single vendor and that there's the right kind of opportunities for people to the way that you move through becoming a maintainer or whatever is really well documented so people understand how it works. But CNCF itself doesn't sort of make any rules about how a project is governed. As opposed to there are other foundations that take different approaches and maybe really specify all the roles and all this sort of thing. But CNCF sort of tries to be pretty lightweight in terms of describing how a project is run, and really only I think dictates in places where we really believed it was important, like code of conduct.
Sweet. Okay.
Yeah.
Well, I think that's our time today. Really, thank you very much, Brendan, for your time. And I do want to share a couple of links, if I could, on my screen.
Absolutely.
Before we get going here. Let me see. Right here. There's a couple of things I wanted to tell the viewers about. There we go. So there is a Learn module. So Microsoft Learn is where you can learn these self-guided tutorials. I'm going to share some links in a second, but this is a really cool Learn module. It takes you all through what is Kubernetes, how it works, when to use Kubernetes for those of you who are new to it. There's this other thing that is called the Kubernetes Learning Path, which is very cool. It's this downloadable thing that takes you from 50 days from zero to hero with Kubernetes. And by the way, they're produced by Microsoft, but it's mostly generic Kubernetes topics. So you could run this. Once you learn about this, you could actually run it on any platform. Yeah. Although Azure is our preferred one. And one of the cool things I saw here, for those of you who might not have seen this, a lot of people have, but the Kubernetes story, Fippy Goes to the Zoo. Have you seen this? This is pretty cool. It's a kid's story, and it talks about how Kubernetes works, and it basically educates you and your children, if you want, on how Kubernetes actually happens. So I'll post those in the chart right now. Do you have anything to add to that? Or?
I was going to say, and just credit to Karen Chu and Matt Butcher, who are both on the Azure team, and we're deeply involved, and actually did at KubeCon last year, I think it was, did a sort of fireside story reading of this book, which was pretty cool. You can probably find it on YouTube if you go looking for it. Matt had his cardigan sweater on and everything. It was perfect. And I also wanted to say, like, the 50 days from zero to hero, it doesn't have to take 50 days. If you want to move through that one a little faster, you can go through that one a little faster. So don't be daunted by the fact that it says 50 days. It's like 50 days in very bite-sized chunks. So, and it was great. It was great chatting with everybody. And as always, you can hit me up on Twitter. And happy to chat more about everything Azure, Kubernetes, and open source.
Yes, absolutely. Thank you very much. That was wonderful. And I just want to take us to the next spot. I posted the items in chat, so thank you, Brendan. Next up, we have Sean Mckenna, the Principal Lead Program Manager at Kubernetes Service, which is Azure Kubernetes Service. He's going to talk about recent announcements and roadmap. So we can bring up Sean, who I hope is showing up backline.
Hello, can you hear me?
Hey, there you are.
Oh. You hear me okay?
Yes, yeah.
Perfect. So should I just take it away? I'm doing great. How are you?
Doing great, thanks. Yeah, so today you're going to talk about Kubernetes Service and roadmap. And
Yes. Yeah, so again, I'm Sean Mckenna. I run the product team for AKS, and it's actually great that you showed in the last session, just towards the end there, some of the learning resources, because in my 30 minutes, we're not going to be able to cover everything required to learn Kubernetes. As suggested, it can take up to 50 days, although you can speed it up. So what I'm going to specifically focus on is some of the things that we've announced recently and some of the things that we have on the roadmap. So this is, I think, going to be more useful for folks who are already sort of following along with AKS, but maybe are struggling a little bit to keep up with the pace of announcements. So I'm going to highlight a few of the things that we've launched recently that folks aren't familiar with, may want to go take a look at.
Okay. Hey, Sean, we need you to share your screen so we can.
That's important. Let's do that.
So just while Sean's doing that, I will be sharing some links in the chat for viewers related to what Sean's talking about today. So take it away, Sean.
Cool. All right, so there's a whole bunch of recent announcements. This is probably over the last maybe 2 to 3 months, so fairly recently. I'm going to dive into a few of these specifically and try and do some demos of some of these items. But I wanted to call out a few of the ones that I'm not going to go too much deeper on, but just kind of flag them for folks so they're aware. The first one is in the top left there, AKS on Azure Spot. So people may be familiar with Azure Spot as a VM option. This is a way for you to pay less for your VMs, which is always good. And the deal that we make is you pay less, and in return, we are able to take that capacity back if we need it for somebody who's prepared to pay full price. So this actually works out really well with Kubernetes and containers because typically your applications are built to be a little bit more resilient to interruption, and Kubernetes has this control loop desired state model that can deal with that churn and try to get you back to a good state as the compute comes back. So definitely something to look at for those workloads that can afford to be to have a little bit of that interruption. The next one I want to call out is confidential nodes in the middle towards the bottom. This is sort of an initial foray into this space of running containers and Kubernetes on trusted hardware. And basically what that means is that applications can have a set of memory within the hardware that is isolated even from higher privileged processes. And that includes processes that are running on the physical host. So the idea here is even though we're running in Azure, we're running all of that infrastructure for you. If you have really sensitive applications, you don't even want to trust us as the platform operators. You can run those applications in that trusted hardware in what's called an enclave. And this is really about bringing that now to Kubernetes, and kind of speaks to the idea of making Kubernetes a base compute platform for all types of applications, and being able to leverage the broader set of infrastructure innovation that's happening within Azure. And then the last one is actually the one just below that, Kubernetes 119 GA. We take it as sort of a point of pride in the AKS team to try to keep up with the fairly frequent pace of releases from the upstream Kubernetes community. And that's really, the reason we do it is because there is so much great work that's happening upstream, not only from Azure engineers, but from the dozens, if not hundreds of companies and individual contributors who are participating in this incredible project. We want to make sure that AKS customers can consume that value as soon as humanly possible. So we're trying to make those new releases available, usually on the order of a few weeks in preview, and then shortly thereafter to GA within the managed offering. So you'll continue to see that type of pace from us going forward. So I'm going to dive into some of the specific announcements recently, but I want to kind of put it in a little bit of a framework in terms of how we're investing. And I'm going to talk about each of these in turn. So the idea of a more managed Kubernetes solution, security, which is obviously always critical, enterprise readiness, and then this notion of unified management. So we're going to step through each of these in turn and try to do some demos along the way. So the first is this idea of more managed Kubernetes, and Brendan actually alluded to this a little bit in his session. Is the idea of customers now are coming to Kubernetes, and they hear about all of the power of the platform and the capabilities that it provides, but they also can be a little bit overwhelmed by the complexity, the learning curve, and just the number of things you need to be aware of as you're operating it. And so more and more, they're looking for us to provide a more managed solution, a more opinionated solution, one that comes with a set of guardrails and guidance for how to be successful. So there's a whole series of elements of this, including the GIF that's showing here on the screen is around integration with Azure Advisor to get some of those best practices recommendations. The thing I wanted to show today, which is a fairly recent thing that we've added, is what we call the Resource Explorer view. So this is within the Azure portal. You can go and see an AKS resource, and so this is what you would have been able to see for AKS resources for a while. But what we've added now is underneath here Kubernetes resources. Let me see if I can zoom in on that. You can see we've added the notion of Kubernetes resources, which are not Azure resources, right? So these are Azure resources is the cluster and the VMs and the VNets and so on. Kubernetes resources are your namespaces, your deployments, your services, your pods. And so what we've done is try to blur that line a little bit so that you can now see those same set of resources, what you would have historically had to go to either the Kubernetes dashboard or to the kubectl CLI tool to be able to see. You can now see that directly integrated here in the Azure portal. So if I go into, say, services and ingress, that is going to load up the set of services that I have in this cluster. So here I've got the Azure voting application from our tutorial. It's showing me the IP address that was created for that. So I can just go ahead and pop that open, interact with this very complex and sophisticated application, and be able to directly see those resources right here. Now, obviously, that application, that service is being backed by a set of Kubernetes deployments and pods. So I can see that here under workloads, and specifically that front end UI that you saw is being powered by this Azure Vote Front deployment. So I can come in here and see that, and I can see the underlying pods that are powering that. And I can actually even see logs streamed directly from those pods right here in this experience. So I can just choose a particular pod that I want to see logs from. If I go back over here and do a little bit more interaction with the application, you'll see those logs are starting to stream in here directly from the Kubernetes API. And so all this data is point in time view, exactly what you would see if you were interacting with, in this case, the kubectl logs command with the kubectl CLI surfaced here. Now, obviously, since that's point in time, you're often going to want to look at some historical data and be able to say, okay, actually I had an issue yesterday or over the weekend. I want to be able to go back and see those logs, and maybe they've already been aged out from what Kubernetes is directly showing you. That's where something like Log Analytics can step in, and so you can see this helpful link right here that'll actually let me jump over to the Log Analytics view for that same pod and be able to see all of the logs here, which I can then do my very sophisticated Kusto queries on top of, and look at logs that stretch back, however long I've got logs maintained within Log Analytics. So a nice kind of seamless blend of that point in time observability view that is directly built in, and then the more historical view that you can get if you've adopted Log Analytics. Then the last thing here is that what I've shown so far is just kind of a read-only view. I can actually come in here and manipulate the YAML associated with that deployment. So change it from what I was at originally, which is 1 replica, go to 3, and I can actually see, similar to what you would see like in VS Code for making that change directly here in the UI, confirm that, make the change, and that's going to go directly apply that at the Kubernetes API, and you can see it's already scaled out to an additional 2 pods within that deployment. You can see the associated event here. And so just a nice way to interact in a more visual form, like I say, similar to what you would do with the kubectl CLI, but directly here inside of the portal. So great learning tool, as well as for when you're doing some sort of poking and prodding on your cluster. So next up, I want to talk a little bit about security. And so this is a job that's really never finished to make the environment secure. It spans across a whole series of domains, from sort of the development time to moving into your CI/CD system, how you think about managing container images, doing scanning, how you control access to the environment, and so on. And Brendan alluded to a number of the investments here and things like pod identity. I'm going to talk today specifically about the investment that we're making in tying together the Azure Arc system with Kubernetes. And so if you're familiar with Azure and have been using it, you're probably familiar with the notion of Azure Arc roles. You've got owner and contributor and reader and so on, and then a whole series of more granular roles associated with that. We've now integrated a set of built-in RBAC roles, as well as the ability to create custom roles within that Azure RBAC model in such a way that you can actually use it with your Kubernetes environment. So let me just quickly demonstrate how that looks. And this is sort of in the same spirit of what we just saw with the portal, which is starting to really blur these lines between what's the Azure domain and what's the Kubernetes domain. Originally, they were sort of 2 islands. We're now trying to bring those closer and closer together. So what I'm going to do here is do an AKS get credentials on a cluster called RBAC. And this is going to actually ask me to, because this is an AAD enabled cluster, so this is going to ask me to log in via AAD to authenticate. Well, I guess I've already authenticated. So if I hadn't already authenticated, it would ask me to, actually, I think it'll be part of. Yeah, so if I hadn't already authenticated oh, there it is. Okay. Sorry, I lost a little bit of track of the flow here. So this is going to ask me to log in via AAD to this cluster. And do that here. And I'm going to have to do 2-factor auth to be extra secure. Okay, so that should be approved. And now if I go back over here, it's going to go ahead and try to, now that it's authenticated me, it's going to go ahead and try to query the Kubernetes API to get the list of pods in the cluster. And if all goes to plan, that should initially be denied. So there you go. So you can see that I actually don't have permissions to be able to, I've authenticated as myself, but I don't actually have permissions in the cluster to be able to pull the set of pods. And you can see it's giving me this error message here to say, okay, you got to go ahead and get access, get authorized to be able to perform that action. So if I jump over here now to the portal, and here's that same cluster that we were looking at. If I go over to access control and do add a role assignment, this is very familiar if people are used to the Azure Arc model. This is where you would go and give access to various resources. So you can see here, there's a set of the AKS cluster roles that are really about how you interact with the AKS service, the AKS resource provider. But then you can also see these RBAC roles that we've introduced. And if you hover over the little information bubble here, you can see an explanation of what those roles actually imply. So in this case, I'm going to do reader access, which is going to give me basically read-only access to a bunch of the resources in the cluster. So go ahead and save that. It's going to add that role assignment here. And then if I go back over here and try again, now it's probably, in this case, where I'm trying to get pods, it's probably still going to fail because it caches that particular request. It might take a few minutes for me to be able to actually pull pods. So I'll take a different resource here. So in this case, services, which will force it to do that role assignment check. And you can see there it's able to now pull that resource. And so that's integrated. Yep.
Sorry to interrupt. We're getting some feedback that your text is very small, kind of hard to read it. Can you bump that up a little bit on the brand in there? Yeah, that's beautiful. Thank you. Cool.
Yeah, you can never know with these 4K monitors how it's going to turn out. So that's now blending that Azure Arc model with the Kubernetes model. And where this really gets super powerful is obviously the Azure Arc model is tied into the overall Azure resource model. And so in this case, this RBAC cluster is actually part of this Learn TV demo resource group. And so I can even go up here and do the same thing and provide that same reader role, which is right here, and give that to myself. And now that I've done that, actually, that role assignment is going to cascade down onto the other clusters in that same resource group. So this is a really easy way for you to manage, if you've got that hierarchy of resources, to now be able to give common access across, say, a set of clusters within a resource group or within a subscription, and have that, like I say, all sort of cascade down to the underlying resources. So the third area is around this notion of enterprise readiness, and it's sort of a broad kind of topic, but it's about bringing the power of Kubernetes into the enterprise and being able to work with the set of controls and desires that customers have in that environment. And so the thing that I'm going to show today, which is a fairly recent release, is under the sort of section of cost optimization, which is a really big focus these days. Folks are trying to tighten up the budgets given some of the economic circumstances that are going on. And so one of the patterns that we saw from a lot of customers recently is people trying to figure out a way, hey, I've got all these clusters, dev test clusters or batch environments or what have you, that I don't use all the time. So I've got a fairly predictable usage pattern for those clusters. I want to be able to shut them down when I'm not using them. And so we saw people trying to do that in sort of ad hoc fashions. So we decided to just introduce that as a first-class capability that we call AKS Start Stop. So this one actually takes a few minutes. I've got a demo video here that I'll speak to. The idea is I've got a cluster that's up and running that has a set of services. In fact, it's got that same Azure voting app that we saw earlier. So this cluster is up and running. It's got a set of agent nodes running associated with it. I'm obviously being built for those agent nodes as they're running, right? And so now you can imagine I'm going home on Friday afternoon, and I want to be able to shut that cluster down because I'm not going to be using it over the weekend, right? So I want to shut these nodes that you can see here from the kube-control get nodes. I want to shut those down such that I can avoid that billing on the weekend and then be able to bring it back up on Monday. So I can do a fairly simple command here, AKS stop, provide the resource group and the cluster name, and that's going to go and start to shut down all the associated agent nodes, which you can see already happening there. And it'll do a cordon and drain such that the workloads get shut down gracefully. Once all the agent nodes have been shut down, then actually we'll start to shut down the control plane as well. So the piece that's running within the managed infrastructure, that'll get quiesced as well to the point where there's nothing running at all. But critically, we're actually maintaining all of the metadata that was in the control plane. So everything that was stored in etcd, but what applications were running and the configurations of those applications, we maintain, we back it up, so that when you come back in on Monday and want to start the cluster back up, you can do just an AKS start and have that cluster get fully rehydrated, which follows the same process in reverse. We'll get the control plane back up and running. We'll re-provision the agent nodes, which then we'll start the billing meters, obviously, and then Kubernetes will then do its thing, which is following that control loop to go drive towards to the goal state that was defined in that metadata. And so once you've done that, then you can see the application comes back up and it's running as it was before. So the other way to do this obviously is to just completely delete the cluster and re-provision it from source. And that's certainly you should always be in a position where you can fully recreate your environment from source control. But the reality is there's often these kind of dev test environments, POCs, that type of thing, where you're still kind of tinkering with applications and you may not necessarily want to go back in all cases and be driving everything through CI. And yet you want to be able to get the cluster back up to a good state once you need to use it again. So just a kind of a nice little feature in the context of that larger sort of cost management umbrella that I mentioned. Then the last thing I'll just briefly touch on here, because I know Jason is coming up next to talk about Azure Arc, and so this is kind of a little bit of a segue, but we're trying to build a set of capabilities that tie together some of the capabilities that we have within Azure and the Azure resource model, things like Azure Arc that we saw earlier, and bring those out to other environments beyond AKS. So again, trying to blur the lines between what you can do in the sort of first-class managed service with what you can do with any Kubernetes running anywhere, so that you can take a lot of those capabilities and the power that we bring to the managed service and bring some form of those out to the edge or to other cloud environments. Again, I think Jason's going to go much deeper on this topic. So wanted to kind of wrap up quickly with a set of things that we have on the roadmap. Some of which are actually, I think, going to be touched on in other sessions today. So OSM, for example, I think Phil's going to talk a little bit about that, but we intend to integrate that into the service as our managed service mesh solution. We're going to be adding support for Hyper-V isolation for Windows containers, which is really important for that Windows solution, particularly around ensuring backward compatibility as you move forward between different Windows options. So there's a number of other items here that we'll touch on. Maybe the last one that I'll call out is actually in the bottom right corner. This notion of portal quick starts is an idea that we're working on to provide you, and again, this speaks to the idea of sort of best practices and easy to get started and more managed environment, to provide you with some pre-configured templates depending on what type of cluster you're planning to run, whether it's a dev test cluster, something that's going to be used for machine learning, for batch environments, for some large-scale microservice type architecture, because there's a bunch of different configurations that we would change depending on that. And so if you can give us a little bit of a hint for what you plan to use the cluster for, then we can put you in a better state with respect to those best practices. So that's some of the kind of top level roadmap highlights. I also just want to do a quick plug for our presence on GitHub. We are trying very hard to be pretty transparent about both our roadmap as well as our releases. So if you go out here to the 2 links that I listed, you can see a fairly detailed roadmap of the things that we're shipping, what's in GA state, public preview, coming within the next kind of month or 2, further back on the backlog. And you can also submit issues there as well that we'll take a look at. So definitely if you want to keep up with the service at a fairly detailed and granular level, that'd be a good place to do it, as well as to say, be able to see the release notes as we ship roughly every week with bug fixes and new feature capabilities. So definitely check that out. And then last but not least, set of resources, some of which Brian pointed to earlier, but a lot of great learning content out there, kind of regardless of where you are in your journey of learning Kubernetes and learning AKS, whether you're brand new or looking for some of the more complex sort of best practices type topics, advanced topics. All of those are out there for you to take a look at. So definitely would encourage you to look at those. And that's basically it.
Thank you, sir. Sean, that was great. I do have a couple of things. I'll share my screen here. A couple of things that you just mentioned, I just wanted to highlight. We have a couple of minutes left. There is a learning path for Microsoft Learn, Introduction to Kubernetes on Azure, and I have posted the links for this in the chat. And basically it just covers everything to know about Docker, Kubernetes, Azure Kubernetes Service, and what you can actually do with Docker and Kubernetes on Azure. So it's a pretty great learning path, very useful. Also, there's some great docs, and I've included a link there as well. Kubernetes core concepts, and there's a whole section in, if you go to docs.com, just search on Kubernetes, or you can look at the link I just shared in the chat, and that's there as well. But yeah, that's great. Thank you, Sean. That's fantastic. Do you have anything else you want to add on these, on the docs or learn?
Yeah, just to highlight again that it is a process. It's an important investment for people to make to ramp up on Kubernetes, and then eventually the specifics of AKS. It is something that we think is worthwhile, but it's good to know going in that it is going to take some time, and that's okay. It takes everybody time to learn this stuff, and so hopefully some of those resources that can take you step by step from the very basics to get you up and running with a single application to, like I say, some of those really more advanced sort of day 2 topics it will allow you to ramp that at your own pace. Absolutely.
Well, thank you. Thank you very much. Next up, we have Azure Arc. It's recent announcements, Arc-enabled servers and Kubernetes. We're going to talk about GitOps as well with Arc and AKS. And as always, I had a few questions in the chat. Slides, demos, and links are going to be at AKS, the launch space Kubernetes. I posted that in the chat a little while ago. I'll do it again in a minute. But you can find all the links and copies of the decks. They're not all there yet, but they will be. And anything else you might find useful related to these sessions. Any of the links we're sharing today are going to be there as well. So AKS, launch space Kubernetes. And next up, Jason and Chris are going to talk to us about Azure Arc. So welcome, gentlemen.
Hello. How's it going, Brian? Can you hear me?
I can hear you.
Perfect. Hey, everybody. Yeah. I'm Jason Hansen, and I'm joined by Chris Sanders. We're both PMs on the Azure Arc team. And the plan for this session, I'm going to give a little bit of an overview around what Azure Arc is, what we're doing, why we're doing it, and some of the scenarios that we've implemented, as well as talk about some of the most recent announcements and previews that we have up and running, with links for you to be able to kick the tires on that. And then we'll pass it over to Chris, who's going to demo some new scenarios that we have around GitOps and GitOps across Arc and AKS.
Great. Looking forward to it. We'll see you at the other side.
All right. Let's go ahead and get stuck in. So as I mentioned, my name is Jason Hansen. I'm a PM on the Arc team. And again, just want to set some context around what Azure Arc is and why we're doing what we're doing. And really, this comes from our customers' experience that their environments and their needs of their applications are continuing to evolve. And that evolution is happening across a number of different vectors. First is the sheer number of applications that our customers are running across a number of different form factors. So they could be doing some new stuff in containers on top of Kubernetes, maybe writing some serverless applications. We're still, dealing with a large number of, say, line of business apps that are running in virtual machines, and again, across a number of languages and runtimes. Now, increasingly, those applications need to run across lots of diverse infrastructure. And so that could be, your existing investments in data centers. That could be hosting providers that you have, MSPs or CSPs that are running your infrastructure for you. Or commonly, we need to run a lot of applications close to, a specific location. Now, in manufacturing, that could be a factory floor or a typical office location. Again, lots of apps, lots of different locations. And increasingly, we also see customers that are adopting or embracing a multi-cloud disposition. And this could be either because you need a specific capability from one of the cloud providers, or you need to get your applications closer to a specific set of customers serviced by a particular cloud, or you're just looking for a business continuity and disaster recovery standpoint, set of scenarios. Now, across the board, with all of these various moving pieces across all of this infrastructure, and the question for our customers is, how do we govern and operate across these disparate environments? How do we ensure that security is enforced across the entire organization? And at the same time, how do I make sure that my developers remain agile? Now, the Azure perspective here is that Azure Arc is going to help us attach Azure management services and our Azure-based control plane to these various infrastructures running in lots of different locations. And so all up, we see the Azure platform as being purpose-built for a hybrid set of scenarios. And Azure Arc helps us manage and operate your infrastructure from that Azure control plane, and additionally runs Azure services on your infrastructure as we start to bring Azure services downward. So this really there's two streams within this flow. The first is Azure Arc enabled infrastructure. And this is all about attaching servers and Kubernetes clusters that you have running in lots of different locations or on other cloud providers into Azure. And then once that infrastructure is attached, we can start to bring Azure Arc enabled services down into your environment, really giving you kind of the attached resources and then bring management services down. Now let's go ahead and look at, from a high level architecture, what this looks like. Now, this is the Azure platform. On the left, we have Azure customers that use tools and experiences like the CLI, the portal, all the Azure APIs. Those tools and experiences interface with this control layer, and this is the control plane. Now, we call this the Azure Resource Manager, and Azure Resource Manager sits on top of and governs resources. Now, resources are anything inside Azure. It can be a virtual machine, it can be a Kubernetes cluster, it could be a database, it could be HD Insights, Azure Container Instance, a container registry. These are all resources. And the Azure Resource Manager uses that resource interface to be able to list those resources consistently, apply role-based access control, apply tags, and place those resources in Azure subscriptions or Azure resource groups. And again, no matter what that resource type is, if we add or remove resources to the Azure platform, that Azure Resource Manager provides a consistent experience for that. And today, again, those resources are running in Azure regions. Now, if we look at the very top box in Develop and Operate, we have a set of Azure-based management services. So this is services like Azure Sentinel, Azure Security Center, Azure Monitor, Azure Backup. These services govern or provide additional capabilities across a set of services. And the reason that they're, resources. And the reason that they're able to do that is, again, this control plane layer, where all of the access to these resources are governed by Azure Resource Manager. So again, as we add additional resource types, those Azure-based management services can wrap their arms around it. Now, how Azure Arc fits into this picture is like, here, Azure Arc builds a set of connective tissue to bring resources that aren't running in Azure regions. So again, running on a different cloud provider, running in a data center, running in a remote office, branch office, exposing that infrastructure into the control plane layer. Now, once we've done that, again, these develop and operate services up on the very top box can now start to wrap their arms around that Arc-enabled infrastructure. So what kind of infrastructure types do we support today? So we have three that are out in preview. We have three that are implemented. The first is Azure Arc enabled servers. And this is a GA offering. And this allows you to attach any server. It could be bare metal, it could be a virtual machine, it could be Windows or Linux, attach that server into Azure. Once you do that, by deploying the Azure Arc machine agent, you can see your Azure-based virtual machines and the servers and virtual machines that are running in your own data centers side by side. And again, consistency is key here. I can see everything in the portal. I can use Azure Role-Based Access Control to govern who can and can't see those particular servers. And then again, bring to bear some of those Azure management services. Now, the second offering that we have is Azure Arc enabled SQL Server. And this is much like Azure Arc enabled servers, but it's purpose-built for SQL servers. Again, organization, inventory, and monitoring are all Azure consistent. With extensions into the SQL Server running it on that box. So that again brings best practices and analysis into the Azure portal. It brings monitoring so that again you have a consistent experience running on Azure as well as your SQL servers on-prem. Last but not least is Azure Arc enabled Kubernetes. By attaching a Kubernetes cluster running on your own infrastructure or running on another cloud provider, you can see your Arc-enabled Kubernetes clusters side by side with your AKS clusters. Again, tagging, grouping, role-based access control are all consistent. So single pane of glass for your entire portfolio, no matter where those resources happen to be running. Now, additionally, in terms of those services that we can bring to bear, Azure Monitor for containers, Azure Policy for Kubernetes, and our GitOps configuration management service can now start to run consistently across both of those form factors. Now, in terms of support for Kubernetes clusters, our MO here is bring us a CNCF conformant Kubernetes cluster, and you should be able to deploy and run the Azure Arc operators or agents in that Kubernetes cluster. Now, we've also worked closely with some distribution providers in the space, which includes Canonical Charmed Kubernetes, Red Hat OpenShift, and Rancher environment to make sure that the Azure Arc agents work well on their kube distros, and that we have some mutual testing and validation back and forth. As well, so from a first-party standpoint, we have a number of offerings like AKS and Azure Stack HCI, which you'll hear a little bit more about later today, as well as Azure Stack Edge, where we've baked in the Arc agents by default. So again, you get that consistent experience for portal, for GitOps, for monitoring, and policy. Now, I want to talk a little bit about some of the scenarios. We've covered some of these and want to just poke in a little bit. So for Azure Arc enabled servers, really it's all about reach. So again, Linux and Windows, virtual machines, and bare metal. And again, if you can deploy an agent to that machine and that agent has line of sight to the Azure platform, you'll see that resource pop up in the Azure portal. And from there, you'll be able to, again, start to manage it. Now, one thing for Windows folks, this is a domain agnostic management. So if you have Windows servers or Windows servers that are not domain joined, you can deploy the agent, you can bring them up in Azure and start to manage them using Azure Policy, which is a pretty powerful scenario. In terms of organization and inventory, again, all of the abstractions that you have on the Azure platform are available to you. So where we talk about subscriptions, management groups, resource groups, all of those work seamlessly with Arc-enabled servers. And additionally, if you're doing management on behalf of where you're managing a subscription, you can use tools like Azure Lighthouse. Again, this demonstrates the power of integrating with the Azure Resource Manager, and that control plane gives us a broad set of flexibility in terms of what management services we can bring down to our infrastructure. Next, to talk a little bit more about governance and security. One of the nice things that now that you see these resources surfaced in Azure Resource Manager, we can use Azure Policy to govern these resources. And some of the things, if you're not familiar with Azure Policy, this allows you to make statements about your infrastructure. For example, I want to ensure that any server that is attached to the specific subscription has a secure password, or I want to audit certificates that are running on machines and surface a warning or alert if a certificate is going to expire in 45 days. Those policies can be described in Azure and applied to various scopes, which again gives you a lot of management control and flexibility about the resources that are attached to your Azure infrastructure. And last but not least, role-based access control, which allows you to say, describe who can and can't see a particular resource, which allows you to say, central IT can see all of the servers that are attached to my Azure infrastructure, but only specific workload owners or application teams can see a specific set of resource groups. Now, again, some of those services that I haven't called out before that are lit up by Arc enabling your infrastructure: Azure Policy, Defender, Sentinel, Azure Monitor, change in inventory tracking. Again, the power of Azure Arc here is that as Azure continues to make investments in our cloud-based management services, those services can be broadly applied within your organization. All right, let's talk a little bit more about Arc-enabled Kubernetes. We've talked about Connect. So again, any CNCF conformant Kubernetes, as long as it can run our container workloads, will be able to be registered with a portal. Configuration, which Chris will cover all around GitOps. Operation and monitoring, Azure Monitor for container integration, observability into the dashboard, and again, consistent role-based access control, not only for the cluster itself, but can be baked into use Azure Active Directory to govern access to resources. All right, so we've talked a little bit about infrastructure, and just one thing that I want to highlight, we talked about Azure Arc-enabled services, and one of the premier services that we have in the Azure Arc family today is Azure Arc-enabled data services. And what this does is it brings the Azure SQL managed instance capability that you have on Azure infrastructure today and starts to run that in your own environment. So for example, if you have data governance requirements, or you've got sovereignty requirements, or just latency requirements, but want the benefit and capability of a managed database as a service for you, you can now start to run that in your own environment. Again, this stands up and deploys into any Kubernetes cluster. And if that's Arc enabled, we again have that consistency across the board. So that's a quick overview. I want to go ahead and tee it up now for Chris to go ahead and dig in and do a deep dive. Actually, I missed a slide. I got to talk about the most recent updates. I'll tee it up for Chris. Apologize. So new updates, Azure Arc enabled servers. We've got alerts for Azure Arc. So you can define an alert on your servers. We have an Azure Key Vault extension, which allows you to attach or grant access from a server up to Azure Arc, to Azure Key Vault for fetching and keeping certificates up to date. We also have the vulnerability assessment across your servers, which is now available in public preview. In private preview, we're working toward deploying the next version of the Azure Monitoring Agent for folks who have been following that on Azure. Now, coming soon, we have private link support. So this allows you to attach your servers on-prem to a private endpoint so that there's no direct internet access required, as well as support for Windows Server 2008. Now, if you're interested in any of those previews, I've got some aka.ms links for you to be able to sign up and access the private previews. No, on the Kubernetes side, we've got a few things in public preview. We recently added outbound proxy support. So if your clusters need to go to Azure through a public proxy, that scenario is now supported, and all of our agent container images are now fetched from Microsoft Container Registry. In terms of private preview, we've got a few things that we built and we're testing out with customers. First is cluster extensions, which again gives you a unified interface for installing offerings like Azure Monitor for containers or Azure Policy. We have Cluster Connect feature, which allows you to use a cloud-hosted endpoint to be able to interact with any cluster running on your infrastructure using standard Kubernetes tools. And then the scenarios that Sean showed earlier in terms of AAD-based authentication and authorization for resources, we have a private preview up and running for non-AKS clusters. And then last but not least, which is what I was teeing up before, GitOps for Arc and AKS clusters. So with that, I'm going to go ahead and hand it off to go ahead and get away for the GitOps demo.
Hey, Jason, before we get going with Chris, we do have a question from the audience. Girish is asking, can we upgrade a set of Kubernetes clusters in Arc all at once? And if you're going to cover this later with Chris's demo, that's fine, but just a quick question.
Yeah, I'll just tackle that at a high level. So right now with GitOps, if you can check in a resource into a Git repository, we can apply that to one or more Kubernetes clusters. What we don't support today is cluster lifecycle management outside of that GitOps scenario. It is something that we are definitely evaluating and working on. And if you are interested in what that might look like, please reach out to me. I'd be happy to talk to you about your requirements for cluster lifecycle management in more detail.
Awesome. Thank you, Jason.
Welcome, folks. Chris Sanders here, Program Manager working on Azure Arc with Jason. I'm going to give you a demo of some of the new GitOps capabilities that are coming along soon. Just to level set, again, Jason showed this figure about the basic value prop from Azure Arc enabled Kubernetes. A similar value prop comes from Azure Kubernetes Service as well. And what I want to, that your resources show up in the Azure portal. You can configure and manage them, and you can operate and monitor, and you can govern and secure. And what I'm going to focus on is the configure piece here using GitOps. So just to level set again on what GitOps is, it's a process for managing your Kubernetes clusters based on Git repos. And so what you are doing in this process is you're saying that Git is going to be your source of truth for your Kubernetes clusters. And that means that all of your updates and changes to Kubernetes objects within your Kubernetes clusters are going to happen through manifest files that are checked into your Git repo. So that means that Git becomes the single place where you operate. That's where the creates, the changes, and deletes happen to your Kubernetes cluster. What that means is that because these changes are in Kubernetes manifest files, YAML files, all the changes are observable. You can see exactly what the state of the cluster should be, and you can also see changes from one commit to the next and see what has changed within the cluster. Then within the cluster, there's an agent, and the agent that we use is Flux. That agent is monitoring the Git repo, and when it sees a change in the Git repo, a new commit, it pulls down the files to the cluster and applies the changes to the cluster. That same agent is also a desired state configuration agent, so that it's constantly monitoring the state of the cluster and comparing it to the state that's declared in your Git repo. So if the cluster has drifted from that desired state, then Flux will restore the state of the cluster to the desired state. So this is the core idea behind GitOps. Here's what a GitOps workflow looks like, where you have your Kubernetes cluster, and there's an instance of Flux, the GitOps operator in the cluster, and it is monitoring your Git repo. And then you're either a cluster admin or an application developer, and you commit your Kubernetes manifest to the repo, and you build your container images out to your registry. And Flux then notices the changes, pulls them down to the cluster, and applies them through the Kubernetes API. So this is the core idea. It's a pull model from your Kubernetes, from your Git repo. All the changes happen through your Git repo. They don't happen through kube control apply and Helm update directly to the Kubernetes API. So the new capabilities that we have related to GitOps. And with Azure Arc enabled Kubernetes, which is in public preview, GitOps is already enabled. You can already go out and use GitOps to configure the cluster and to deploy your applications. What we're doing now, and it's going to be coming within the next couple of weeks with a private preview, is the ability to use GitOps also in AKS. So your Azure Kubernetes Service Managed clusters can also use GitOps. And what this means, and you can enable the GitOps in an AKS cluster through using the AKS add-on model, just like you enable other add-ons within AKS clusters. This is important because now you can extend your GitOps and your management of applications and configs across all of your Kubernetes clusters, AKS clusters, and Azure Arc enabled clusters, which means basically all your clusters located anywhere. We've also added some new authentication scenarios. With the current release of Azure Kubernetes Configuration Management, aka Azure GitOps, we supported public repos and we supported SSH with keys that were generated by Flux. What we're adding now is SSH where you can bring your own private key, SSH where you can bring your own known host file. So for instance, if you're hosting your own instance of say Bitbucket that is protected by CA cert, then you can bring that known host down to the Flux pods so that they can authenticate that that self-hosted Git repo with Flux. We also support HTTPS basic auth, and the agent tree also now supports communication through your outbound proxy. This is all important because now we support, customers have different implementations of Git repos. They have different implementations of security. And so now all of the core scenarios are supported within the Azure Kubernetes Configuration Management agent tree. So let me go to a demo. The demo that I'm going to show kind of mixes, the new features that are coming in AKS and also the ability to connect to one of these self-hosted Git repos. In this instance, we have an instance of Bitbucket running, and we're going to authenticate with it using our own key, our SSH private keys, and we're also going to supply a known host to the Flux agent tree so they can authenticate the Bitbucket repo. So let me switch to a different screen. Okay, so first I'm going to show the Azure portal here. I've got a bunch of clusters. I've got some Kubernetes service clusters. I've got some Azure Arc connected clusters. And first thing I'm going to do is show you this one here. This cluster here I created this cluster, but I haven't set up GitOps on it. So the first thing I want to show you about this AKS cluster is in the private preview, you will have now in the settings area, the ability to enable GitOps. And so for this cluster where it's not enabled yet, you would go in here and you would click this. And there's also a CLI command that I'll show you here in a second. And then after a few minutes, you'll have GitOps enabled on this cluster. Let me show you one where it's already enabled just to save some time here. If I go down here, go to GitOps, you can see that for this cluster, GitOps has already been enabled. And just as in an Azure Arc enabled Kubernetes cluster, you see the same page where you can go in and you can start adding configurations to this cluster. So let me go back to this to Visual Studio code here, and what I want to show you here is this is the case of that cluster number 4 where GitOps was not installed. So let me run those. And what you see here is that you're not seeing a config agent pod and you're not seeing a GitOps manager pod. So this one has not had it installed at all. So let me go now. I don't have time to install because it's a relatively short demo. If I was going to install from the CLI, I could use this command right here, AKS enable add-ons. And the new add-on we've added to AKS is the GitOps add-on. So this here, running this command would enable the GitOps add-on, and it takes a few minutes. And then you'd be ready to start making GitOps configurations in that cluster. So let's now go to a cluster, that cluster 3 that already had GitOps enabled. And you can see here that we have the GitOps manager, and we also have the config agent. The config agent is the agent that is listening to the Azure service for your request to create a GitOps configuration on that cluster. And when it gets a request from you, it uses then the GitOps manager to actually manage the installation of Flux to track the Git repo that you had configured. If we within the same cluster, you can see here's the core namespaces that are in there. There's four namespaces. These are the ones that always show up in AKS clusters. And what we're going to do now is we're going to create a new GitOps configuration in this AKS cluster that has GitOps enabled. Again, it's going to be to a Bitbucket repository. We're going to use SSH with a user-provided key. And we're also going to provide the known host file to authenticate the Bitbucket repo. Just real quickly here, just to show you the new commands in the CLI. If you're using the AZ CLI, you can see we have new commands in here now for HTTPS key and HTTPS user. If you wanted to use HTTPS, you would provide the basic auth key and the basic auth username. If you wanted to supply your own known host file, there's SSH known hosts, or you can add the core contents, or you can upload a file. Yes.
Sorry to interrupt. We're just seeing the demo screen on the PowerPoint. We need to switch to the, I think it might be on another screen if you're using two screens, so you can actually see the demo part.
Okay, I shared my entire desktop with this.
There, yes, now we're looking at Pubble, I believe, or StreamYard.
Okay, well, I'll go and I'll unshare and I'll share again.
Okay, cool. Yeah, something went wrong there. It was just
I had shared mine.
It was just showing the slide, the demo slide.
Okay, so share screen.
Yeah.
And my entire screen. Okay. What do you see?
I'm not seeing the screen share right now. Juliet, do you want to? Okay. I think you're just showing right now. You're just showing StreamYard. Is it? Are you using two screens?
What do you see now?
Good question.
I don't have two screens. I have one screen.
Okay.
So what I'm showing now is Visual Studio Code window.
Hey, okay. We're not seeing it. Not sure what's happening.
Okay.
Juliet, do you want to show the screen share? What's showing them right now, so we can see what it is? Yeah. So for some reason, it's only showing StreamYard. It's only showing the streaming service.
Apparently, it's only showing exactly what. Okay, let me try again. So I'll try to share again. So share screen. Okay, share screen. So I can pick my entire screen or an application window. So
Let's try
my entire screen.
Okay.
And I select the entire screen and I go share, and that's.
Okay.
And here's.
Can you try
the power?
Can you try doing just a share of the application? Just stop screen and then share the application with just Visual Studio Code. See if that works.
Okay. Basically, StreamYard here is not seeing my apps at all. It only sees the.
Okay.
That's
You know what?
right.
It's live. This is what happens in live sometimes. Apologize to all the viewers and to Chris as well. I think what we'll do is we'll fix it in post. We'll add a video later of the actual demo, if that's okay. And we'll just, we'll move on to the wrap up for now, because I'm not sure what happened there, but we can fix it later.
No problem. Okay, cool.
So Jason's back. We've got a few links there for getting started. And,
Sure. Yeah, I'll quickly talk about the links that we have, and I hope you enjoyed the theater of the mind version of our GitOps demo for all of you D&D players out there.
Yeah.
We put a natural one on live demos and screen share, but hey, you know, appreciate everybody hanging in with us. Yeah, so what we got again is some links to the Arc-enabled infrastructure that I mentioned, as well as a call out for trying Azure Arc-enabled data services. We have this Jumpstart repo. It's the fourth link down. The Jumpstart repo is an open source GitHub repository that has a number of scenarios implemented that allows you to see, managing Kubernetes across multiple cloud providers, as well as GitOps scenarios that go along with it. There are scripts in there which include, Terraform to provision a demo environment. And it's really awesome resource, tons and tons of scenarios there for you to kick the tires. As well, we have the technical documentation, which just links out to the Azure Arc documentation repo. And then much like Kubernetes AKS service, we have an Azure Arc learning path, which is in its infancy. Definitely go kick the tires and at least get some high level concepts there. And we're definitely interested in feedback in terms of that learning path.
Sure. Thank you. Thank you, Jason. Thank you, Chris. Much appreciated. I also posted a few links in the chat for those of you who want live links right now, and a copy of the slides are out on our site as well. So next up, just sharing my screen quickly, we have AKS on Azure Stack HCI. Abhilasha Agarwala, the program manager of Azure Edge and Platform, is going to be joined by Nick Wood as a principal software engineer and Zach Wachtel. Nick and Zach are special guests. And let's get going with Abhilasha's session, AKS on Azure Stack HCI. Abhilasha Agarwala is going to take us through AKS on Azure Stack HCI. And a little bit later in this session, Nick Wood and Zach Wachtel are going to give us some details as well. So take it away, Abhilasha.
Thank you, Brian. Hey guys, I'm Abhilasha, and I'm here with Nick and Zach to talk about our new product, AKS on Azure Stack HCI. As the name suggests, we're all about running AKS in your very own data center. Now, before I start talking about AKS on Azure Stack HCI in earnest, I want to take a couple of minutes to talk about the motivation behind building it. And the simple reason here is people want to use AKS in their data centers. If you have an on-premise infrastructure, I don't need to tell you that not all applications can run on cloud. Many existing applications are simply not connected to Azure, while for many more applications, business needs dictate that they run in their data centers. However, when developers get AKS in their data center, they do not want to lose on AKS consistency, and admins don't want their jobs to get 10 times tougher. We do not do these things. When it comes to the developer, AKS on Azure Stack HCI is consistent with AKS. AKS and AKS HCI share the same upstream code repository and support the same Kubernetes versions. We have also worked on providing an AKS consistent user experience. So if you learn to use AKS first, all those learnings can be applied to AKS HCI and vice versa. When it comes to deploying your applications, AKS HCI supports running Windows and Linux containers in the same workload cluster. Finally, AKS HCI natively integrates with all great Azure technologies like Azure Arc, Azure Monitor, Azure Policy, and many more. Now, when it comes to the administrator, and maybe this also applies to the developer, AKS HCI is a fully inclusive offering that is very easy to deploy. We use deployment tools like Windows Admin Center and PowerShell. So if you're familiar with Windows Server or Azure Stack HCI, you should feel right at home deploying AKS HCI clusters. As I've mentioned before, AKS HCI can run both Linux containers and Windows containers out of the box, and all of this infrastructure is managed for you. All of this also comes with a single support statement and a single vendor to talk to if you encounter any problems or need any assistance. Last but not the least, AKS HCI is secure out of the box, and we manage security for you. AKS HCI also gets to take advantage of all the security investments we made on Azure Stack HCI to make it an incredibly secure platform. Now let me step you through the entire Microsoft hybrid solution. We work with partners for validated OEM hardware that then runs Azure Stack HCI or Windows Server 2019 data center on top. We then have AKS and Azure Stack HCI running in virtual machines that are all automatically updated from Azure and managed for you by Microsoft. You can now run and build apps in your very own data center. On top of this, we have Microsoft first-party offerings running, again, in AKS HCI. And one of them is Arc for Data Services, which is a container-native data platform that you can use in your applications. This is one of the many upcoming exciting products that Microsoft is working on to strengthen hybrid scenarios for you. Lastly, we provide two management tools to manage all of this: Windows Admin Center and Azure Arc. If you're looking at an on-premises-based management experience, Windows Admin Center is an incredibly lightweight on-premises management tool. If you're looking at managing your resources through Azure, Azure Arc is a single pane control pane for your servers, VMs, and Kubernetes clusters. Now let's try actually deploying AKS on Azure Stack HCI. I have over here a Windows 10 machine with Windows Admin Center installed on it. Let's first start Windows Admin Center. And as I've mentioned before, it's a remote management tool used to manage Azure Stack HCI or Windows Server anywhere at no additional cost. You'll see that I've already added my 2-node Azure Stack HCI cluster to Windows Admin Center. Before logging in to start cluster deployment, let me first sign into Azure. So navigate to Settings. And then as you can see over here, I've already logged into Active Directory. Let me log into my Azure account too by clicking on Sign In. Here, I have multiple accounts, so I need to choose which one to use. And then once it reviews your permissions and I accept it, we're good to go. So I can now navigate back to Windows Admin Center, and I can now log in to my cluster to start a deployment. And you'll see the AKS extension on the left-hand side. Yep, right there. So you can click on Setup, and then you have 5 steps. Step 1 walks you through the prerequisites to get started with the deployment. Here you see a checklist of all the resources you need, both on the Azure Stack HCI that hosts AKS, as well as the Windows 10 machine that runs Windows Admin Center. It also tells you about networking requirements, as well as firewall ports that will be open for deployment. So take a second to just go through this. And once you've confirmed that you have these requirements down, we move to the next step. Here you give back access to the AKS HCI cluster so that it can check if the resources that were asked for in the previous page were indeed available. So let's wait a couple seconds. And once it finishes validating the password, yep, it's now checking. And so just briefly going through the checks here. So it looks like I have all the checks satisfied on the Windows Admin Center gateway server, which is the Windows 10 machine. And yep, I have everything running on the Azure Stack HCI node too. Moving on to host configuration, here I need to provide a management cluster name. AKS HCI deployments also require shared cluster volume. WAC looks at all such volumes for you, and then you can select one from the dropdown. This location is used to store the VHDs that will be used for the VMs in the management as well as workload clusters. As you can see on my screen, I've also enabled automatic updates, so Microsoft can manage updates for me. The next step in host configuration is VM networking. Here, you specify the virtual switch used by your VMs, whether you want to tag VMs to a VLAN ID, and if you want to use MAC pools. As for DHCP or static address support, Windows Admin Center currently only supports DHCP. Static IP address is currently in preview only on PowerShell. Finally, you can choose to define a pool of IP addresses apart from DHCP for your load balancer. Now, once you've specified networking and configured storage, we're now ready to move to the next step, which is Azure registration. While this page asks for an Azure subscription, there is no cost for setting it up and using AKS in public preview. After you've made your selections, select Next. Review all your selections so far in the Review plus Create step, and if you're satisfied with what you've selected, select Next to begin host setup. While this is deploying, let's go to Nick and Zach, where they talk about how open source is a core part of AKS on Azure Stack HCI.
Thanks, Abhilasha. Hi, I'm Nick Wood. I'm a principal software engineer and one of the dev architects for the AKS on HCI project. And as we began looking into how we can bring AKS to Azure Stack HCI, one of the challenges we faced was that we didn't have all of the infrastructure that exists inside Azure. We needed to figure out how to bridge the gap and bring similar capabilities to Azure Stack HCI as we have in Azure. So today, while we won't be able to cover all of the building blocks that we've developed, from our Microsoft on-prem cloud stack and cloud SDKs to Kubernetes operators, add-ons, Arc, custom containers for billing, we do want to take a moment to just talk about one area of focus within the project, which was around the deployment and lifecycle operations of the Kubernetes clusters. This starts with our management Kubernetes cluster that we deploy as part of day zero product installation, and through to the workload clusters that we deploy to host Linux and Windows customer workloads. So as we considered the requirements of the project and the types of day zero and day two operations that we're likely to need to perform on the Kubernetes clusters, we explored a lot of different technologies and solutions. Ultimately, we ended up adopting several open source projects across the HCI product. For example, we've adopted Flannel CNI, HA Proxy, KubeVip, and several other great projects. But one of the projects I do want to take a moment to spotlight is Cluster API. If you aren't familiar with it, Cluster API is an open source project focused on providing a declarative Kubernetes-style API that automates Kubernetes cluster creation, configuration, and management. It's a really cool project. It's one of the key concepts that they bring is that of an infrastructure provider. So essentially, you can, or the various public clouds and on-premise clouds will be able to develop their own infrastructure provider implementation, bring it to the Cluster API project, and this code will provide the ability to create networking, storage, and compute resources on the relevant cloud environment. So once you have an infrastructure provider for your cloud, Cluster API can orchestrate calls through that provider implementation and drive the creation of the cloud resources it needs to bring up Kubernetes clusters and to manage them. So to take an example, just to bring up one Kubernetes cluster control node, you would need to, say, perform a sequence of operations on the cloud to potentially create a new resource group, to obtain a load balancer address, create a network adapter, a virtual hard disk, and of course a virtual machine. And inside of that virtual machine, you probably need to do some bootstrapping, like a custom cloud init script, where you can provide the Kubernetes configuration and execute something like kubeadm to initialize the Kubernetes clusters. So pretty much all of that orchestration of that flow is handled by Cluster API, and the implementation of how those computational resources are realized on the cloud and what order they are created is actually handled by the specialized infrastructure provider for the cloud. So as part of this AKS on HCI project, we have developed our own Cluster API infrastructure provider, which calls through our cloud SDK to the new on-prem cloud stack we've developed, and it orchestrates the creation of resources on the HCI cloud. And this cluster provider runs alongside the core Cluster API pods within our management Kubernetes cluster. And we're developing all this code for AKS HCI in the open. We've open sourced both our Cluster API provider and our cloud SDK on GitHub, and we've presented our provider to the Cluster API community. This is really important to us. We believe strongly in open source, and we're really excited to be embracing projects such as Cluster API and to be a part of that community. We do see this as a journey, though. We're still exploring, we're learning, and as we gain experience and develop new solutions in this space, we want to be able to share those learnings back and contribute to the communities as much as possible. So with that, I'll hand over to Zach to talk about some of the development work we are doing and the learnings we've had so far that we are hoping to share back to the community in the near future.
Thanks, Nick. To introduce myself, hi, I'm Zach, a software engineer here at Microsoft. I work alongside Nick on AKS on HCI. Our venture into Cluster API and delivering a vendor-managed Kubernetes distribution started with testing out Cluster API v1 Alpha 2. Before I can even get into Cluster API, we had a bigger blocker. Azure Stack HCI doesn't have any ARM infrastructure. To combat this, we had to develop cloud-native friendly agentry to run on our physical host. We call this the Microsoft on-prem cloud stack. Getting back to the infrastructure provider model Nick was talking about, we needed to create our own provider, which we would call our on-prem cloud Microsoft APIs. So to bootstrap this provider, we use KubeBuilder. KubeBuilder is a framework for building Kubernetes APIs using custom resource definitions. This allowed us to rapidly develop our infrastructure provider. The controller tools and controller runtime libraries made it seamless to define our own custom resources and then write code that allowed us to reconcile its desired state. Following these patterns and resources used in other cluster API providers, we were able to get our provider up and running in no time. Next slide. There were a few open design questions we found during this process that made us a little bit different than other providers at the time. First, we had no native load balancing solution on Azure Stack HCI without the inclusion of SDN. We looked towards the open source and developed various integrations with HA Proxy, Keep Alive D, and we're helping to grow communities in newer projects like KubeVip. Second, we didn't have a cloud provider. Kubernetes traditionally had cloud provider code in tree, but lucky for us, there were movements in the community to support external cloud providers, which allowed us to build a custom solution for Azure Stack HCI. After getting past those roadblocks, we had a working cluster API provider for Azure Stack HCI. Next slide. The next challenge we had was getting from cluster API running on Azure Stack HCI to a seamless managed Kubernetes experience, such as AKS running on Azure Stack HCI. Luckily, cluster API is an extensible API that can serve as the building blocks for a managed Kubernetes service on top of it. So from there, we brainstormed how we could create a seamless deployment experience for an Azure Stack HCI user. We went through various iterations of messing around with combinations of temporary bootstrap machines, kind clusters, and interesting cloud-init scripts. Eventually, we landed on a method that would allow for us to optimize the deployment process and cut out the need for any bootstrap cluster and only create a management cluster. Once we figured out the flow for the deployment of a management cluster, we had to get to the fun part and figure out how we could easily create target clusters or workload clusters and do day 2 operations. Around this time, Cluster API v1 Alpha 3 was released, and we realized the community had completely rewritten this tool, Cluster CTL, which is a command line tool that helped the deployment and lifecycle of Cluster API. It also would centralize the process of creating target clusters by providing a method for creating and templating the resources for provisioning a cluster. Next slide, please. We were also tinkering around more with KubeBuilder and CRDs, and watching the success that we have with Cluster API, we were curious what else in our deployments would benefit from an operator-driven approach. Using Cluster CTL as a backbone, we then created an operator to install and upgrade Cluster API and declarative model. We called this the cloud operator. We also use this operator to simplify cluster creation UX and to dynamically provision Cluster API custom resources. We also kept Cloud Operator as generic and interface-driven as possible to allow for its code base to be adopted by other Cluster API providers. Finally, we had the control plane layer that we needed to expose to our higher-level callers and users for both the lifecycle of management and target clusters. Next slide, please. One last checkmark that was necessary for AKS and HCI was support for Windows nodes, since we are Microsoft. At the time, there was no support for Windows in Cluster API. So we created a proof of concept in our infrastructure provider to create custom data, which would allow for Windows worker nodes to join the cluster. Once we got that working, we teamed up with the open source friendly folks from Cloudbase, which owns Cloudbase and init. Cloudbase and init allows for Windows guest OS to be provisioned with the same methods as Cloud init. Working with Cloudbase, we were able to figure out a flow that allowed for Windows worker nodes to join the cluster in the same way that Linux worker nodes can. Next slide, please. We have learned a lot with the open source throughout this journey. We have built code on top of and toyed with ideas in Cluster API and we would like to contribute back to the Kubernetes community. In addition to Cluster API, we've also heavily invested in various cluster lifecycle and API machinery projects around it, such as kubeadmin and controller runtime. In v1 Alpha 4, Cluster API will be working officially on bringing support for Windows worker nodes and an operator for Cluster API management cluster. While these features that we already have in production, we realize now that we need to do a better job of developing our solutions in the open from the start to help the strength of the Cluster API project and the cluster lifecycle community around it. Some of the code we developed for alongside Cluster API is opinionated to support AKS and HCI, but a lot of it is generic and should be given back to the community. Some improvements we would like to develop with Cluster API and the Cluster Lifecycle projects are improvements to add-on support, operating system upgrades for machines, optimized management cluster bring-up, and the lessons and learnings from the management cluster operator and Windows node support. The needs and demands of AKS and HCI are growing, as well as the needs and demands for Cluster API, Kubernetes, and the cloud-native communities. The only way to ensure customer success is to be in lockstep with the greater communities to develop high-quality solutions in the open to allow for greater growth. And lastly, last slide. I just want to give a shout out to all these fantastic projects that we've been using and all the developers that have been contributing and maintaining these projects. All right, back to you, Abhilasha.
Thank you, Zach and Nick. It's always amazing to hear about all the work that goes into building a new product. Let's check back on our AKS management cluster deployment. We now have successfully deployed a management cluster in your data center in 45 minutes. How incredible is that? Here, before we go create a workload cluster, you can see that all the packages were first downloaded to the gateway machine, that is the Windows 10 device running Windows Admin Center, and it was then transferred and installed on the Azure Stack HCI nodes. The last item in this workflow was spinning up a management cluster using the installed packages and binaries. Now let's click on Finish. And once you click on Finish, you will be redirected to a lightweight dashboard that contains your deployment details. So here you can see that you can check deployment details such as the Kubernetes version, memory, and Azure details. It's asking me to log in again because of the time lag. Now that you've seen how a management cluster is deployed, let's now use the tool to deploy a Kubernetes workload cluster. Here, let's click on Add Cluster to start a workload cluster deployment. And once the page finishes loading, we can see the prerequisites page again we saw during the management cluster creation. Briefly reading through this, let's now go to Basics. Here you see the option to connect your clusters to Azure Arc. Azure Arc extends on-premises resources to Azure, so you can then enjoy Azure services like Monitor on your on-premises Kubernetes cluster. To enable Arc, select a subscription and resource group from the dropdown. You should also have the option to create a new resource group if you choose to do so. You can now provide cluster details like cluster name and Kubernetes version, as well as give Windows Admin Center your login details to start a deployment on your HCI nodes. So just giving in my login details over here. And while the password's getting validated, we support 3 Kubernetes versions right now, and I'm choosing the latest one. And we're now going to configuring the primary node pool. The primary node pool are Linux control plane nodes that will manage your workload cluster. Here, you can enter the number of control plane nodes as well as VM size. However, for public preview in this current release, this option has been disabled. So as soon as the password has finished validating, we will proceed to create user-defined node pools that will actually run your workload applications. So now we can add a node pool here. We can add up to 1 Windows and 1 Linux node pool in public preview, in addition to the system node pool we configured earlier. However, if you've enabled Arc like we did, we need at least 1 Linux node in the Linux node pool for Azure Arc to function. Here, as you can see, you can again select the node size, which is basically the VM size, as well as the node count of your Windows and Linux node pools. So I've selected 1 each with the same default VM size option. I click on Add, and then I can proceed to networking. On the networking page, you can select Advanced if you want to customize the address range used when creating a virtual network for nodes in your cluster. But if you select basic, then the nodes in the cluster will be created with a default address range.
We're back. We had a little bit, it looks like we're having a little technical difficulties with that playback. Not sure what happened there. I guess we'll just move on. The one thing I wanted to show you, if I could share the screen here, is I posted in the chat a doc. These are some great docs on the Kubernetes Service Azure Stack HCI documentation. There's all kinds of information here on getting started, and there's also some information here on setting up different things, working with PowerShell, several quick starts you can use as well. With that, I'm going to move on to our next session, which will be coming up in a minute. So that was Abhilasha, Nick, and Zach. And the next session we have is actually OSM integration with AKS, which is with Philip Gibson. And he's going to be talking about open service mesh integration with AKS. We'll get started with that in just a second. Greetings, Philip. How are you, sir?
Hey there, Brian. I'm doing well.
Looking good with the, that's not the new Apple headphones, I assume. That's the...
This is Surface all the way. Come on.
Anyway, no big deal. Those are nice. I have to get a pair. I don't have a pair yet. I do definitely need to get one. Yeah, okay. So let's get started with the next session. So you're going to be talking about OSM integration with AKS, and got a little bit of some Q&A that we can do at the end, and some links as well. So take it away, Philip.
All right. Thank you, Brian. Hello, everyone. My name is Phil Gibson. I'm a senior PM here with the Azure Compute Upstream OSS team, and I am joined by the one and only Dalian Raychaz. He's a principal software engineering manager with the Azure networking team, and his team has been really instrumental in getting us to where we are today. And Dalian, he's also going to be moderating the chat for us today. So personally, if I were you, I would bring the heat to that conversation. Dalian is more than capable, and he's looking forward to interacting with everyone. Let me get my slides going there. Here we go. Okay, so when we decided to venture into creating a service mesh for the community, Michelle Nurali, you may know her, she came up with these key concepts or principles that we wanted to always keep focus on as we kind of developed open service mesh to what it is today. And the first one here was we wanted to make something that was simple to understand and contribute to. Secondly, we wanted something that was effortless to install, maintain, and operate. Third, we wanted something that was going to be painless to troubleshoot. And finally, we wanted something that was easily configurable via the SMI specification. And overall, we believe that we've done a really great job in simplifying the service mesh onboarding and operating experience. And we're committed to adhering to these core principles moving forward as we enhance OSM. So let's talk about the OSM journey because it feels like we've been at this for a really long time. Back in August 2020 is when we open sourced the project out to the community, and it was well received. And we got some really good positive feedback from that open sourcing. And then soon after that, we were able to petition the project to be involved with the CNCF, and we were happy to report that we were accepted as a CNCF sandbox project, and that's in September 2020. And so today, I wanted to announce that we will be having the OSM add-on in limited preview starting in January 2021. So thanks. I think I may have heard some virtual claps and cheers there. But we're really excited to be working with our Azure customers to test this out, provide some valuable feedback, and really experience a service mesh that's fully managed with the AKS managed service as well. And so where do we go from here? The OSM journey continues. We're really looking to level up our observability and tracing with Azure Monitor. And then we're looking at some really deep integration into Azure Arc. I think Jason Hansen hinted at some of that in his session earlier. So there's some really unique customer use cases that we think we can unlock with Azure Arc. So I'm not going to steal those teams' thunder. Just please be on the lookout for some future announcements for those two teams here in the near future. Next, we're looking to do more SMI functionality. You know, again, OSM is really about taking the rocket science out of managing and operating a service mesh. So we're looking to expand the SMI spec, not only to enhance the OSM, but also enhance all the other service meshes that are adhering to the service mesh specification as well. And then last, we're looking at multi-cluster support. I've been on several calls with a lot of customers. We know that this has been a constant ask, and I just want everyone to know we've been looking at this intensely, not only in the open source upstream core, but also how we can actually leverage the Azure platform and really take advantage of our global data centers footprint and a lot of the high availability capabilities of Azure. So definitely we're looking at this, and we're looking at the right approach to make this custom experience really, really well with multi-cluster. So enough for that. I know everyone wants to see this demo, but prior to me getting into the demo, what I want to do is I thought it'd be good to kind of show a visualization of what this demo is going to be, because the demo is command line, so you're going to see a bunch of text flying back and forth. But what we're going to do is we're going to start off, we're going to create a brand new AKS cluster, and then we're going to deploy the infamous bookstore app. So we'll deploy that into the cluster. And that's going to deploy out 3 services. We're going to have our book buyer, our bookstore v1, and bookstore v2 service. And then next, we're going to then do the add-on for OSM. And the key here is the default mode that the OSM add-on is going to be is in permissive mode, being true. And so what that means is as you onboard your namespaces into the OSM mesh, we're not going to throw any policies onto the Envoy sidecar proxy. So your application is going to be able to continue to talk to the other services that it's talking to today. And the key around this is we really want to show you that brownfield environment to where you can understand that you can actually onboard the OSM add-on without adversely affecting your applications. So then we'll onboard both the book buyer and bookstore applications, namespaces. And then we're going to go and do the redeployment of all those 3 services, and we'll get this Envoy sidecar proxy put into those pods. And then we'll do a smoke test and make sure that the book buyer is still able to talk to the bookstore v1 service correctly. After we verified all that, what we're going to do is we're going to flip that bit to false. And what that's going to do is it's now going to have OSM look for an explicit rule to have communications happen in the mesh. And so we'll, again, look at the logs coming from the book buyer, and most notably, we'll see errors where it's trying to talk to the bookstore v1 service. Once we verify that, we'll go ahead and deploy our SMI traffic target policy into the mesh. And then that's going to then enable that book buyer to then talk back to that bookstore v1 service. Finally, what we'll do is we'll sum this up. We'll do an actual SMI split policy. So we'll enable another path for the book buyer to speak to the bookstore v2 service. And then we'll also weight those services as well. So you'll see a 25% going to the bookstore v1 and then 75% going to the bookstore v2. And so with that, it is demo time. And so let me go ahead and get the demo up and going here. I got a ton of windows open, so that took a while. Okay, and so let's go ahead and kick off the demo, and then again, I'll go ahead and kind of narrate through it. So what you're seeing here is we're going to start off and create our resource group, since we'll be deploying a brand new AKS cluster. And then once we have our resource group, we'll go ahead and deploy or create our AKS cluster. And pro tip for everyone out there, if you want to create a super fast cluster on Azure, use ephemeral disks. Your provisioning time gets cut really low if you do so. And so that's just going to take a minute to deploy out. And then once we have our cluster, what we're going to do is we're just going to do the normal stuff. We're going to get our credentials, ensure that we have our focus on it in our config file. And then we'll do the infamous standard smoke test, which is just get the nodes and make sure they're running and ready. So I'm getting my credentials, and obviously I've done this a couple of times, so I got to overwrite some similar content there. And then next, we're just going to check our current context in our config file. So that's our brand new cluster there, my OSM add-on demo. And then our quick smoke test, we got 3 nodes there. They're up and running. They're ready to go. And then finally, right here, this is kind of just, as a magician would say, nothing up our sleeves. What I'm going to do is I'm just going to query the actual add-ons for this AKS cluster. So again, this is a vanilla cluster. So we'll get an enumeration back here, and we should see absolutely nothing, which is true. So we have no add-ons onto this cluster. And so now let's go ahead and make this a greenfield environment. And again, what this is going to showcase is we think that most people are going to already have their AKS clusters already running. You're already going to have your applications running. And so we're going to get to that state so that you can kind of see what happens here with existing applications running. Here, I'm just catting out the spec file. So this is simple stuff. We're creating namespaces, service accounts, some deployments, and some services. And this is all available on the OSM repo, by the way.
Hey, Philip, sorry to interrupt real quick.
Yeah.
Is it possible to make your text a little bit larger? It's kind of hard to see on some screens.
Yeah, fortunately, I'm not sure I could do that. This was a pre-recorded, so the text is kind of static, unfortunately. Sorry, I thought I had bumped that up when I was recording it, so apologies for those that are struggling to see that. Is it okay to continue on there, Brian? Okay. All right, so here we're deploying out the Bookstore app. And then we'll just do a quick smoke test on the Bookstore app as well. So we're just gonna look at everything in the Bookstore namespace, ensure all our pods, services, deployments, everything is looking okay. And then again, to just test the communication, make sure the book buyer is able to talk to the bookstore, we're gonna go ahead and filter in on the book buyer pod. And then what we're going to do is then we're going to tell the logs coming out of that pod, and then that will show us talking to the book buyer. And again, we're just confirming that the book buyer is talking to the bookstore, and we are. And again, apologies if you can't see the text, but one of the attributes here that we are logging out is the server attribute, and you'll notice that it shows NA, and that's actually our proxy configuration. So right now there is no proxy between the book buyer and the bookstore, and you'll see that change once we enable the mesh here going forward. So now let's go ahead and clear that screen, take it to the top, and now this is what everybody's been waiting for. We're going to now enable the service mesh, and this should be very similar to all the other add-ons in AKS. It's the enable add-ons, and we call this add-on the open-service-mesh. That's going to run for just a second here. And so now we've deployed the add-on, and we're just going to query to just ensure that that add-on is in place. So we're just going to query on into the add-ons profile, looking for the open service mesh add-on and seeing what its enabled status is. Okay, so that comes back true. So everything is fine for now. And so now let's go ahead, now that we have the add-on enabled, the thing that we want to do is we'll do a quick smoke test here just on the OSM controller. And again, this is running in the managed portion of your AKS cluster. So we'll just view the deployments here real quick. So there's our OSM controller. We'll take a look at the pods. And then we'll take a look at the service endpoint. Okay, so everything's looking good. And then finally, what I wanted to show here is the config map that gets deployed along with the OSM add-on. So you're going to be able to change the configuration of the add-on currently right now via the config map. And the big thing I want to show here is what I spoke about earlier is that permissive traffic policy mode. And you'll see that that is equal to true here. And again, that means that we're not putting any policies on the Envoy sidecar so that have been injected into your application. So next, let's go ahead and onboard our namespaces for both the book buyer and the bookstore. And here we're just checking the two namespaces that we're going to enable OSM for. And next, I already have downloaded the latest OSM binary. So I have that in my path, and we'll go ahead and do the OSM namespace add command to add our namespace to the mesh. And so we got book buyer being successfully added. And we'll go here and do the bookstore. Perfect. And now what I want to show here is from the previous Git pods query, or prior to the Git pods query, sorry, you'll notice here's all of our pods, and you'll notice that they're one of one. So we just have our one container application pod. I'm sorry, container per pod. And so now to get the Envoy sidecar injection, we'll go really quick and do a restart on these deployments. And by the way, Kubernetes is built for this. So even though we are restarting your deployment, depending on your max surge configurations, et cetera, this will not take your application offline completely if it's configured correctly. And so there we go. We got our restart on our book buyer. We'll do a restart on our bookstore v1 service. And that's in the bookstore namespace. And then last, we'll do the bookstore v2 service. Perfect. So now we have a redeployment of our services out there, and we'll go and query those pods again. And you'll now see that we have 2 of 2 for each pod. And that second container is that Envoy sidecar being injected into your application pod. And so real quick, what we'll do is we will just describe this book buyer pod. So, and we'll take a look at the spec. And we'll scroll up into the spec. We'll go to the containers attributes, and you'll see that first containers are book buyer container, and our second one there, just right below it, is our Envoy container. So now that we have the Envoy sidecar that has been injected with our pods, let's now, and again, we're still in the permissive mode being true. Let's now verify that our book buyer can still contact and communicate to our bookstore v1 service. So we'll go ahead and filter back on that book buyer pod. And then we'll go ahead and tail the logs coming out of that pod, and our application is logging that information out. And you can see we still have a successful communications between our book buyer to the bookstore. And you'll notice now that server attribute has flipped to the Envoy proxy. And so that is where the communications is coming from. So great. So again, in a brownfield environment, we've just onboarded the OSM add-on. And again, your application was not harmed at all. Now let's go and do what a service mesh is supposed to do and really control the traffic in the mesh. So we're going to go ahead and patch or update the config map, and we're going to flip that bit from being true in the permissions mode and flip it over to false. And once we've done that, OSM is now expecting an explicit policy to allow traffic to happen. And we'll just go ahead and query just to verify that that has been, the state of that has been flipped over. And you see that it comes back as false. And then now we will tell that same book buyer pod. And now that you see that we are having difficulties reaching the book buyer, I'm sorry, the bookstore v1 service there. And so now the mesh is in full effect. And the next thing we'll do here is now enable an explicit rule to allow the book buyer to speak to the bookstore. And so I'll cat out this file here. This is our traffic split, SMI traffic split YAML. What you'll see in here, there's three things. There's a HTTP route group. I'll come back to that. But below here, we have both of our traffic targets for both of the book buyer to be able to speak to both the bookstore v1 and the bookstore v2. And part of the rules of this traffic target is to actually utilize the HTTP route group that you see here. And what that route group is defining is not only are we talking from service to service, but we can actually control the header payload that service is actually communicating to. So you'll see some regex commands here looking for a particular set of header fields that we are then in addition to allowing traffic for. So let's go ahead and apply those rules. And now that we have those rules deployed, let's go ahead and tail the logs on the book buyer. And you'll see the policy is still kind of replicating out. And then now that you see the policy is in full effect, and now the book buyer can now talk to the bookstore v1 service. So perfect. Okay. So now the last thing we'll do is we will now enable the traffic split. And I'll go ahead and we'll just, again, just look at this traffic split spec. This is, again, all described on the SMI repo here as far as what the activities are. But you'll see below here at the very end, we have two paths going to bookstore v1, bookstore v2. And again, we're going to weight the bookstore v1 path to 25% of the traffic and the bookstore v2 path to 75% of the traffic. So we'll go ahead and apply the traffic split. And now that we have that, again, we'll filter in on this pod, book buyer pod. And then now we'll tell the logs on the book buyer. Now we're going to be grepping for an identity attribute. And just to let you know, we did find, it's not an issue, it's in a way that we were coding some of the output of logging. You'll see here. So some of them come up as identity NA. We understand that that's actually on our part. It's actually part of the bookstore application. But what we should see here is the bouncing back between the bookstore v1 and the bookstore v2 service. Again, the bookstore v2 service has the larger weight, so you should see more of them in this output. Eventually, you will see a bookstore v1, but all of the NAs as well are actually bookstore v1s as well. And we'll do the fix this demo here in the near future. And you'll see, there we go. We got one v1, and I think a couple are trailing after that as well. Okay, so I will go ahead. That's brings us to the end of that demo. And what we will do now is we will go into our Q&A.
That was great. Great demo. Wonderful stuff. And I do have a few questions for you, actually. The first one is, will OSM support VMs soon?
That's a popular one, yes. So yes, we are actually looking at that. Supporting different runtimes has been a persistent question, I would say. What we're doing is we're really working with the community on trying to solve this. So we've had talks with the Spiffy team, and we're looking at how we can actually possibly put this functionality into the SMI spec to make it easier for everyone to allow them to bring in these different runtimes such as VMs and also things like Azure Functions as well. So that is on the roadmap. It's actually, we do have an issue out there in the public repo. But yes, we are looking to open up additional runtimes into the service mesh.
Great. What about supporting multiple clusters with Open Service Mesh?
Again, yeah, that's a popular one. Yeah, so we were looking at that pretty intensely as well, and we do actually, I guess I could say this. I mean, we got some POCs that are doing some similar that have that functionality. So that is on the roadmap as well. And again, we're looking to also bring that into the Azure platform and leverage a lot of the Azure platform multi-cluster or HA concepts as well. So that we have, when someone is using a multi-cluster experience, most likely they want it due to like a high availability situation. So again, we're looking to integrate a lot of that into the Azure platform so that it's a seamless experience for the user.
Great. Right. What about, so you highlighted the AKS add-on for OSM. When will, it's not in GA right now, correct?
No. So we're going into what we're calling a limited preview. There's a bit of some stability issues that we want to resolve. The GA dates, we've not solidified them, but we're looking at possibly the closer to the end of H1 next year. But I don't want anyone to hold me to that. But we should see it definitely available next year, and hopefully before the H2 timeframe.
Sweet. Great. Last but not least, I just want to highlight, in the demo, you showed a bookstore. We're hope we're not giving too much away, but Microsoft's going to start selling books online. We think it's might be exploited, might lead to bigger things. Who knows?
Yeah.
But, I'm just kidding, folks. But I love that it's a bookstore demo. One thing I wanted to show, if I could just share my screen, I do want to highlight things. Over in the launch space, all of the sessions that we've got today, we've got links at AKS launch space Kubernetes. I'll show that link up there in a second. But if you scroll down to Philip's session, I put the links in there. And this is the Open Service Mesh site. We've got a lot of information there, of course, including the CNCF information. And just to highlight, it is open source. It's on GitHub. Everything is there. And I assume you accept pull requests for this.
Yeah, absolutely.
If anyone,
we just had a OSM community call actually prior to this. But yeah, we're looking for anyone that wants to contribute to the project. That's fine. We are building a lot more contributors and maintainers for the project. So definitely, if you want to help, we'll take it.
Sweet. And last but not least, Service Mesh interface. There is a link to that as well. So if you want to have a look at the spec, see how you can link with other tools and check out the ecosystem and things like that, that's all there and ready to go. So thank you very much, Philip. That was very, very informative. And I have posted the chat. One question we had a question from the audience.
Okay.
Is there a UI view of the service mesh like Kiali? And I don't even know what Kiali is. So I hope, Yes.
Yeah. No, Kiali is a great visualization tool for Kubernetes. So, the irony is we are actually looking to work with Kiali, and long story short, we are looking at how we can make a visual UX for OSM, but right now it is all CLI. We're still trying to figure out the best way to do so, but we're looking at Kiali integration as well as some other tools out there as well to provide a UX experience.
Awesome. Okay. Well, great. Well, hey, thanks again for your time. This is really great. I hope, I don't know if you can hear that leaf blower in the background here, but live TV and home offices and all that stuff. But sorry about that. Yeah, it's great. Did you have anything else you want to add in terms of the links or anything else?
No, but again, feel free to venture out to the GitHub repo. Again, on our landing page, we have all of the community information. So our Slack channel is pretty active. Again, you can start joining the community calls. It's a Google Doc. You can put things on the agenda. But yeah, we're really looking forward to working with the community much deeper on this.
Great. Thanks. I did want to highlight one more thing. So that was Philip Gibson. Thank you very much, Philip. Next up, we actually have Mark Schmarny, who's going to be talking about identity management in distributed applications using Dapper. As I mentioned before, you can always find information about the sorry, my screen share here. You can always find information about the of all these sessions at AKS, the Launch Space Kubernetes. And I see Mark's here. Thanks for joining, Mark. And welcome to the session. Please take it away.
All right. So my name is Mark Schmarny. I'm one of the product managers working on Azure here at Microsoft. And so far, if you follow the day of our TV learning here, a lot of the things have been focused around the infrastructure and kind of operational side of things. I want to make a slight switch and kind of focus a little more on the developer side of the developer experience and building applications. So I'm going to share today about Dapper, specifically as far as building applications or microservices with Dapper, and then using identity for the different microservices to manage the access control and the different things that the applications can do. All right, so let's jump into this. A very quick intro in case you're not familiar with Dapper. It's hard to kind of reduce an entire project to a single sentence, but it's a portable event-driven runtime for building distributed applications. Portable, we're going to talk about a fair amount of that. There's a lot of content already online about it. It's a project that was created by Microsoft about a year ago and open sourced. Since then, has grown pretty quickly. There's close to 10 million image pools every month. There is also about 450 or more than 450 different contributors from a broad number of different companies. So if you want to learn more about Dapper itself, Dapper.io is a good place to start. Let's go very quickly into kind of the logical layers of what make Dapper in a form of an introduction into the project. Dapper is kind of agnostic with regards to the language you're using, so polyglot, meaning that you can bring whatever language you're already developing and you're familiar with, whether it's JavaScript, Python, C#, Go, Java, Rust, or whatever else you want to bring in there, and use that language to kind of accelerate or speed up how quickly you develop different services, and kind of make sure that you can use the best practices that are available for that particular architecture. What Dapper does is creates this runtime that you can execute. It runs on any application, on any kind of platform that you want to deploy to. So obviously runs on top of Kubernetes, which we are focused on today, but it also runs on your laptop during the development. It can run on a bare metal VMs, as well as an edge devices, all the way down to Raspberry Pi even. Because it's a framework, Dapper exposes these two sets of APIs. That API have parity between them, so there's no difference of features, but they're exposed through different protocols. So we have an HTTP API and gRPC API, and depending on which language is more, what's your comfort level with different one of those languages and these protocols, you can leverage them in different applications. And you can mix and match, for example, if you're building a microservice application that includes 3 different microservices. One of them could be in gRPC, another one would be HTTP, and Dapper can actually help you with a lot of the translation between communication across those. So let's, the part that I want to spend a little more time about is talking about the building blocks, or these kind of middle layer in here, because I think this is what really distinguishes Dapper from a lot of other runtimes or frameworks or platforms out there. If you've developed applications over the last, let's say, 10 years and modern cloud native applications, you probably have noticed that a lot of the patterns that you're using to build those applications are very reproducible. Every one of your applications has some notion of a service invocation or PubSub. So what Dapper does is kind of codifies these best practices or the common practices and makes them reusable as in a form of a building block, so your application can actually externalize these dependencies outside of its code and focus only on the business logic, which makes you much more effective, allows you to swap these components a lot easier, and obviously increases the overall portability of an application because you're not bound to specific implementation. These building blocks, or these common patterns, are just a facade or APIs that are exposed by Dapper, but the actual implementation behind them can be done through a number of different solutions out there. I'm going to talk about this in a minute. So let's very quickly go through each one of those. For service-to-service invocation, which is basically if you're building an application that includes multiple microservices, you're going to have to be able to discover these services and invoke each other from each one of those services. Dapper provides a service discovery. It provides a mechanism for invocation regardless of the protocol that you're supporting, as well as kind of allows you to obfuscate the kind of location and number of instances that this application runs. The invoking application only needs to know the ID of the application. There's a fair amount of sugar that Dapper adds on top of that around retries and commonality of error controls across different protocols, and throttling, for example, that allows you to kind of focus, again, purely on the development. Now, if you're building microservices and you're thinking that direct service invocation is actually anti-pattern and you don't want to do that, Dapper provides a synchronous pattern for PubSub that allows your applications to, or different microservices in your application, to communicate asynchronously using messages. So what that means is that the publishing application doesn't need to know anything about the backing application, the subscribing application or consuming application, and vice versa. And that kind of increases the overall decoupling and flexibility of the overall application, allows you to, again, focus only on writing the business logic that you need to do. So for service invocation, for example, for PubSub, for example, there is 10 plus different implementations or different component implementations you can use, whether it's something like a Kafka, RabbitMQ, NATS, also a managed services like Event Hub on Azure. After that, if you're writing anything nowadays, you're pretty much going to have a durable state, meaning that as the session of the user expires and the user comes back again, you don't want that user to be just treated as every single time as a new request. So Dapper, kind of in microservice world, the idea of saving that state to their local disk would be a very much no-no. So Dapper provides a kind of a distributed state management, which means that you can rely on this key value stored to be durable. Means your services can, even if they're restarted, they can come back and retrieve the state. We provide implementation for state building block like Mongo, Redis, Postgres, as well as something managed like Cosmos DB on Azure. Next one, if you're building applications and kind of have dependency on different external resources, or even storing any kind of anything sensitive, you're going to need to manage secrets. And managing secrets in a distributed dynamic application tends to be very complex, and that's why we see front page announcements all the time about yet another set of secrets that have been leaked either by committing to GitHub repository or by somebody accessing incorrectly. What Dapper does, it tries to kind of generalize the way you consume secrets, both inside of the user code, as well as inside of the configuration that you describe your application with, and provide a pluggable mechanism by which the different implementation for where you manage the secrets can be pluggable. So obviously, HashiCorp Vault, Kubernetes secrets natively if you're running inside of Kubernetes, but as well as managed services like Azure Key Vault. You can do those without changing the actual application, because again, the application just consumes the very common and standardized set of APIs. Now, these four first patterns being very generic, and you kind of had a very common way of dealing with these things. The implementations are totally different, but the actual way you consume those are pretty common. But eventually you get to the point where you need to consume something that's very specialized and external. And we call those resource binding, and provide an interface inside of Dapper that allows you to interact with those external resources, even though they're very specific. So something like a Twitter API or Twilio API or Kafka or whatever that may be, but still have a consistent way of assuring the configuration of those resources and defining of secrets inside of those resources, or even tracing around and logging around the access to those resources. So resource binding allows you both interact with resources that you want to invoke from your application, which we call those outbound bindings, as well as inbound binding, which trigger your code, for example, based on external event. Let's say tweet was published, you want to consume that. You write a logic that only is responsible for processing the tweets. All the binding of those resources to your application is done automatically by Dapper. Now, because of the way that Dapper is implemented, and we're going to talk about this a little more, Dapper has a full knowledge of the entire knowledge graph or the call graph that it's implemented in your application, which means that it can provide a very detailed observability around both the logs and metrics that you normally would do, but also as well as traces. And that means that without creating any special spans inside of your application, whatever code you're using, you can actually get a visibility around the invocation and the duration of the invocations and counts and so forth. It's a very powerful feature that's automatically enabled inside of Dapper, and you don't have to do anything inside of your code. Again, the focus is on helping you writing the logic that actually makes your application unique. And then finally, we have actor model. If you've kind of followed either the Orleans framework from Microsoft or Akka, you're kind of might be familiar with the concept of actors. Dapper generalizes that concept to the point where the logic and the state is actually combined together. It's a single-threaded model for allowing your application to kind of define a specific functionality. It's very common in IoT devices or something like that. It is single-threaded, so if you're looking for a high IOPS, that's probably not the solution because it's going to be locking. But there's a lot of use cases where that kind of approach works, and you can gain a high density of workloads, thousands and thousands of actors in something that normally would have been just one pod. So that's basically Dapper at its high summary. Let's go a little deeper. So when you start using Dapper, and we're going to talk how that kind of is accomplished, you're kind of creating a virtual API, a sidecar that sits next to you, whether you're running on a local machine or whether you're running on Kubernetes. I know Kubernetes has this construct of a sidecar. We kind of using that same exact approach, whether you're running a local machine during the development or on the edge devices or on a bare metal, because what Dapper does, it creates this sidecar and kind of sits next to you and provides you that API. And like I said, that API exposes this consistent way of invoking all the other resources. We talked about state and PubSub and binding, but also what Dapper does is when you start invoking another service within your application, it provides a secure communication using MTLS across those automatically. So your application doesn't do any secret management, doesn't do any certificate management. It just focuses, again, on the actual logic. So how do you get that magic sidecar we just talked about? Well, first of all, during the development, you rather than launching your normal application in the pattern that you already do, so let's say Node app.js or something like that, you're launching it using Dapper. So Dapper run, there's a few additional parameters you have to provide, like the name of the application you want to use that's going to be known by all other applications, the protocol you're going to be using, a couple other configurations around the components that you're going to be using. That configuration is specific to that one instance of the application, which means that in this in a single application, you can use some components that are specific to that, in another one for another. Now, I wasn't going to list all the examples, but the exact same thing you can do in Python. Eventually, you can actually compile your application running as an executable, whether it's a Windows executable or Mac or Linux. It really doesn't matter, whatever platform you can run. Dapper compiles into obviously the three different platforms, Mac, Linux, and Windows, but it also compiles into ARM and AMD architectures. We're working on, whenever somebody requests a new one, we keep adding that. There's probably 8 or different distributables at this point. Now in Kubernetes, what we want to make sure is that this is very idiomatic, meaning if you're already building application on Kubernetes, you're already familiar with deployment. Deployment is a unit of kind of workload definition for your application. What we do in this case, we actually just using the annotations to allow you to define additional parameters. The very same parameters you were using to launch your application using Dapr run, you can define them as annotation attributes, and those are just launched with your application that allow your application now to create that sidecar inside of Kubernetes and get the exact same API that you had on your local machine. Different mechanism, exact same API, exactly everything works exactly the same. All right, so this was kind of super quick overview of Dapr. There is a full-blown webinar we've done recently that goes through each one of those much more in depth. I encourage you to take a look at that. So let's go into the microservices. I talked about this little as part of the initial invocation, but I want to go a little deeper into this. So if you have something like a front application that using the card application on the back end, and your front application is developing HTTP or exposes HTTP protocol, and the backend card application uses gRPC, what you can actually do is not really even worry about it. What Dapr allows you to do is just use that same exact consistent API, invoke that application. In this case, we're calling the invoke card, and then specify which method you want to invoke on the other service. And Dapr will translate that protocol, invoke that service, take the information, and send it back all the way back. So front to back, dealing with the entire discovery invocation. When, for example, the card application would be overloaded or something didn't work, the retry would be automatically handled. It's configurable how you do it. The throttling between the invocations, as well as error translation. For example, you've thrown a gRPC error, the error was translated and communicated back to the front end using HTTP. Because Dapr is so easy, day 2 or day N, you start having these number of different applications that are all over the place because it was so easy to build those microservices. So how do you create a kind of mechanism to make sure that these services are able to talk only to the right set of services? If you're deploying into like a SAF multi-tenant environment, let's say inside of your company, maybe using namespaces or maybe crossing namespaces inside of Kubernetes. So how do you kind of enable this to be much more declarative and controlled so that you have guarantees around who can access your application at any given time? So we've talked about this fact that Dapr has this notion of a sidecar. These applications are defined by their ID. So we have app1, app2. We talked about the fact that Dapr uses MTLS automatically to communicate between those. What we actually do inside of, in addition to that, is Dapr is leveraging a SPIFFE specification or protocol that identifies that kind of defines the identity of the application in a URI format. And what that means is that we have that SPIFFE identity as a unique identifier for the application that's combined with the trust domain within which that ID was defined. And Dapr used that identity to then kind of identify the applications, both the calling from as well as the invocation policy for when that application is being called. That identity is actually encoded into the TLS certificate. So you have no new kind of way of that you have to look into, but the Dapr automatically packages that certificate the SPIFFE ID into the TLS certificate and decodes it on the other end, so that policy can be simple and plain to write. SPIFFE is quickly growing in popularity. So you've heard already the Open Mesh presentation before this one talked about integrating this in the future. So hopefully we'll have much deeper way of communicating between different projects that it's agnostic to the specific technologies that we're using. So now when you're coming to Dapr, using the SPIFFE identity, you have a deep knowledge of the application 1 being invoking application 2. You can use access policies to control how this who the application is and which type of functionality that invocation can be performed on, because it's all done inside of a trust domain. All right, so let's talk quickly about demo. It's usually good to, when we talk about this abstract technologies, to provide some real world example. This is pretty fully functional application. I'm going to share a link later to a place where you can fully reproduce the entire thing. There's no magic in here. You go in and you follow the steps to reproduce the entire application. But what we're going to do is a simple application that exposes account API that can be invoked externally. It also persists the state across the invocation. So if you come back, that count obviously increments, and also does some back processing using invocation using PubSub that allows the application number 3 to process the submitted events. It has secrets. The components are defined in a different namespace. It has external ingress. So what are we going to do during this demo? Because there's going to be a lot of moving parts. So let's kind of go through this quickly. First of all, we're going to Dapperdize the ingress itself. So allow the ingress, in this case, NGNX, to be able to be part of the larger solution for inside of Dapper. So it will have its own identity, and we can trace the information that are the calls that are being invoked on the ingress. The ingress is going to expose a SSL endpoint. What we're also going to do is internally, we're going to define this trust domain that allows us to kind of treat these 3 applications that are kind of individual as one unit and make sure that they can talk to each other at any given time. We're going to make sure that these 2 applications that actually need to have an access to secrets are the only 2 applications that can access secrets, and only that one specific secret that they depend on, the Redis secret. We're also going to make sure that the state component is only accessible from application number 2, and that a PubSub is accessible from application 2 and 3, and that application 2 can only publish, and application 3 can only subscribe. So very hardened kind of environment that tightly define only the things that can be done. First of all, it says nothing can be done, and then explicitly define what can be done. So enough of slides. Let's do actual demo in here. So for that, what I'm going to do before we get to command line, I'm going to quickly go through VS Code in here and just show the deployment. So let's see if I can make this a little bigger. At some point, this is going to be too big. But what we have here is the actual deployment. You should be able to follow this. Again, a few annotations in here. We defined that, yes, please give us the sidecar from Dapper, application number 1, all the other configurations. But one of the things in here is we're defining that the configuration for the application is actually going to be managed in this configuration object. So let's focus on that. A couple things in here. We say that we're going to have, would like to have a sampling rate for our tracing application, 100%. This is a number between 1 and 0. So 1 means actually everything. Every single code is going to be traced. We're going to say that we want to deny for this first application who doesn't need to have any access to Kubernetes. We're going to say deny everything. No, this application should not have access to any secrets. We're also going to say that this application is going to be part of a trace domain. We're going to deny every invocation except the NGNX ingress, who itself is going to be denied everything except this one method called ping, which only can be invoked over post. And that's the only one we're going to allow. I'm not going to go through this all one by one, but in application number 2, you will see exactly the same thing, saying we're going to allow only access to one secrets. We're going to allow only invocation on a counter over post. The one thing I want to focus on is these components that we've defined before. They're very generic. So you've seen us talking about the PubSub component. In this case, we're using a Redis PubSub component that has secrets. So obviously, we're using the connection string and passwords in here. But the one thing I want to talk about is that to define these complex policy that allows only these 2 applications to be able to use this component, you simply define the scope for that component that can be only accessed from application 2 and 3. You can't make policies any simpler than this. Similarly, for publishing, to limit which application can publish to a topic and which can subscribe, similarly, you do the exact same thing in here. So let's quickly go to our console in here, and I'm going to now that we have this I've deployed this entire stack before because it actually takes a minute to deploy it. But what I want to do is actually demonstrate. Hopefully you can see this. What we're going to be doing is simple curl command against the external HTTPS endpoint that we're going to be invoking the application number 1 with a simple ping request. For demo purposes, this application doesn't have to be any more complex. So when we do that, the entire call stack was traversed, and everything we wanted, we got back from this. There's a count. You can see I've been doing a lot of these demos. That's returned. Now, what I want to do next, though, is show you what would happen if I, for example, try to access. Oops, wrong one. Cut and paste skills are weak. Okay, what I want to do is access now the second application externally, which we know we've kind of prevented this from happening. What Dapper will do automatically is recognize that the policy is not allowing for that to happen. It will send you pretty detailed error, but actually the HTTP 403 is all we need to know we've been preventing to access. Now, you might be saying, hold on a second, you've just shown me an external ingress. Why would I want to do that? Maybe I don't expose my application this way. So what we're going to do now is I'm actually going to forward local ports to the second application. And because now we are kind of inside of the cluster, I want to show you here what would happen if I actually use the invocation, exact same invocation from the application number 2 upstream to application number 1, which clearly is not part of what we enable. You would get exactly same error because the context of the invocation is not physical layer, it's how you got there, but the actual real identity of that application. That exact same principle doesn't work only for service invocation. Here, we're going to try to publish to a topic that wasn't part of our policy. Again, from inside of application 2. Application number 2 is actually allowed to publish to PubSub, but it can only publish to this one message called count. So test doesn't get, we get the error saying that you're not allowed to publish to this one. It works exactly same way for secrets and all the other APIs that Dapper exposed. So in kind of retrospect, you've seen this. It's a pretty, while the logic of the application is pretty simplistic, we're doing simple counts, it kind of is representative of what you would see real life. You have a state, you have PubSub, you have secrets, you have invocation from outside for only one service. So for example, directly invoking to application 2 or 3 was prevented. So it should be pretty real. And here's the link, Dapper demos and aka.ms. You should be able to go in and follow those steps to reproduce the entire demo, including compiling your own images for this application. So in closing, Dapper.io is the single place. If you forgot everything else about the presentation I've given today, is the place to go. The actual project itself is on GitHub and under MIT license. It's all open source. You can take a look at it, github.com/Dapper. There is a pretty robust community of different areas of the interest around Dapper on Discord that you can access. Twitter, Dapper Dev, and there's a bunch of videos that kind of go in depth into specific areas or components or the ways of dealing with deployments in different environments. If you can't find anything else, mchmarney@microsoft.com is how you can get hold of me, and I will connect you with the right people. Hopefully those were helpful.
Very helpful. Thank you. I just want to say I have posted some of those links in the chat as well, so you can access them right now. Otherwise, you can always go to our page, which is aka.ms/launchspace-Kubernetes. And if you share my screen here, I can show you a couple of those different things that that you've just highlighted, actually. So Mark Sessions here, I've got a couple of links to Dapper site and the demos on GitHub. So the Dapper site is here. It's Dapper.io, as Mark mentioned. And you can see the actual repo with his demos as well on GitHub at the link in the chat. All right, so that concludes. Thank you very much, Mark. That was wonderful. I do have a few questions for you, actually, before we go. A couple of questions. You mentioned before, different languages that Dapper supports. What about frameworks that Dapper supports, like Spring Boot or .NET?
Absolutely, yeah. Dapper has, in addition to these very raw protocols like HTTP and gRPC, it has actually a set of SDKs that you can use to interact directly with that obfuscate the protocol plumbing and so forth that are available in C# and Java, Python, Node.js, Go, as well as integrations with framework. Like you mentioned, Spring Boot, for example, has a nice integration for Dapper, as well as .NET itself. And there's a working project on a Python integration into some of the frameworks there too. So much deeper than just language itself, actually providing integration into the kind of plumbing of the framework itself.
Absolutely. Great. Thanks. Hey, we got a couple of questions from attendees as well. Oops. Yeah, sorry. The first one is, what are the components and configuration for Dapper?
So Dapper,
yeah, go ahead, sorry.
Yeah, when Dapper has some primitive set of objects, it really, inside of Kubernetes itself, it depends on the deployment for the deployment, which is the native Kubernetes object. But in addition, when you install Dapper into the cluster, it configures 2 additional or 3 additional objects in there, 2 additional CRDs with few objects. The configuration itself, it has additional ones around kind of the actors and a few other ones. But pretty much that's all it is, pretty light on the integration, and kind of tries to use whenever possible the native objects inside of Kubernetes.
Okay, well, great, thanks. A little more involved question. In case of spiffy identity, what will the context of the SSL with regard to, I believe, domain name and ID? So let me ask that again. So spiffy identity, what's the context of SSL with regard to domain name and ID? There's a couple spelling errors there. I plus them.
Yeah, I would have typed it just as bad. So Dapper kind of automates the generation of the spiffy ID. So we'll use in case of Kubernetes, it will use the namespace plus the trust group that we've defined to create the identity of that particular application. So it's kind of almost guaranteed to be unique. If you're deploying Dapper outside of Kubernetes, you can actually specify a fully qualified domain or the domain that you want to use for that custom certificate. Dapper also supports your own certificate. So you can, instead of relying on Dapper to generate the MTLS certificates, you can bring your own certificates, and Dapper can use those, including integration with service meshes. Obviously, you would have to disable MTLS because that encryption would be provided by the mesh itself, but can work inside of Istio or Open Service Mesh or any other kind of integrations there.
Wonderful, thanks. Last but not least, is Dapper under open governance? I know we mentioned policies a bit, but yeah. Yes,
we actually publicly announced our path to get there. I don't have a timeline at this point. There's a blog post. I will include a link here in a minute where we've talked about this. It's very much the next step. I think we are preoccupied right now with the 1.0 release that's going to be landing pretty soon. We are on a milestone 2 in a couple weeks, I think, or next week. The release candidate number 2, and once the 1.0 is out of the door, I think that's going to be pretty much the first thing we're going to be focusing on. So stay tuned. But we've publicly acknowledged that that's what we want to do. Despite the governance, there is already a pretty broad kind of external number of contributors. They're kind of contributing not only the code, but also to the direction of the project. So many of the kind of hygiene of an open governance, we already kind of are following those principles to make sure that this is ingrained into the project itself.
Great, right. Well, thank you very much. Thanks for your time today, Mark. That was wonderful. And that is the last session in our show today. So thanks everybody for attending. Just before we go, I do want to share the screen one more time just to show the links that you need. So we covered Brendan Burns. We talked about Kubernetes innovation. We talked about the recent announcements with AKS. We covered Azure Arc, some info on Azure Stack HCI as well. We checked out Open Service Mesh with Philip Gibson, and we've wrapped up with identity management using Dapper. So we will have sessions that had a few streaming issues rebroadcast a little bit later. But for now, I just want to say thanks to everyone for coming. And for more information, go to https://AKS launch space Kubernetes. That takes you to a GitHub page, which has all the information here. When we have videos ready, we'll be posting them there. You can also find them on the YouTube Microsoft Developer channel. Just search YouTube Microsoft Developer, and you'll find that. And thanks for joining this Learn TV show. It's been great hosting, and hopefully it was useful information. And please do get back to us with any feedback. Thank you.